studying, we're going to be going into quadratic equations a little bit deeper. So, as I said before, solving quadratic equations is really a mainstay in this class. That is something you really need to know how to do. So, when we solve quadratic equations, sometimes we've had to simplify radicals. And whatever's been under the radical has always been positive. Now, thing is, I've seen some people get negatives that would go under a radical, but unfortunately that's because your work was incorrect. But what we're going to be doing here, we're actually going to be opening things up. If we have a negative under a radical, what we need to do first is take out a square root of -1. And what happens is, obviously, we brought out a square root of -1. The square root of 16 is simply 4. And it's going to be plus or minus 4 times the square root of -1. However, you are not done. There is a special significance to the square root of -1. We're going to be calling this I. Now, thing is, I draw my eyes like this because whenever it's imaginary, rather than doing this, because I don't like them to look like ones. Anytime you have a negative radical, basically you factor out a square root of -1 and replace it with I. So ultimately, the final answer for this equation was x equal to, plus or minus 4i. Now, what is I, and why is it from the square root of -1? Well, I is the basis for our imaginary numbers. So, and no, imaginary numbers are not like 11 or 3012 or whatever. Imaginary numbers actually open things up mathematically. Day one, we talked about real numbers, and we're now going to open things up by adding imaginary numbers to our system. In fact, any number that's real or imaginary is called complex. Complex numbers consist of all real and imaginary numbers in our number system. Generally, complex numbers have a real and an imaginary unit, and they're the form a plus bi, where a is your real component and bi is your imaginary component. B is obviously the coefficient of I. So we have a case where we have complex numbers that have no imaginary component. Those are what we would call pure real, such as 6, 1/3, square root of 15, what have you. Now, complex numbers that have no real component are called pure imaginary. Examples of complex numbers that have a real and imaginary component, 2 plus 3i, 5 minus 4i, 2 plus 3i times the square root of 5. Now, let me give you a little math history background. Yes, I took a math history course in grad school. Yes, such things do exist. Quadratic equations have been around for almost 1,000 years. But imaginary numbers have only been around for about 400 years. So for 600 years, basically what mathematicians did was if they got a negative under that radical, they really didn't know what to do. And they said, well, let's just make it positive. No one's going to notice the difference. Well, Descartes, mathematician and philosopher, realized, when you graph these type of quadratic equations on his coordinate plane, that's why they call it the Cartesian coordinate plane, said, wait, these don't cross the axis. We got to do something. And he was not the one that discovered imaginary numbers. Basically, Euler and Cardano did. So, we're going to look at how to simplify some numbers that have negative radicals. So 4 times the square root of negative 18. Now, I'm going to take this one kind of step by step, and I'm going to factor out a square root of negative 1 and obviously a square root of 18. Now, the square root of negative 1 is I, an imaginary number I. So it's going to be 4I times the square root of 18. Now, surely you know how to simplify the square root of 18. Simplifying radicals was not so much a problem on this test. I didn't see that. But if, to break apart this 18, we know that 18 is 9 times 2. You have 4I times square root of 9, which now becomes 3 times root 2. So basically, 4I times 3, that becomes 12I times the square root of 2. And that's it. So I'm going to give you a moment to try that next one. This one, we can write the negative 1 as its own square root, or what we could just do is get 5I times the square root of 50. We can kind of skip over this step and just take an I out and make it positive. You can do it that way. Now, are there any perfect square factors of 50? 2 and 25, yeah. So square root of 25 and square root of 2, well, we know the square root of 25 is, and square root of 2 is just that. So for that, we get 25I times the square root of 2. And that's it. All right, any questions on this idea? All right. Now, the real and imaginary components. So for 5 minus 7I, what is the real part of that? 5. And how about the imaginary part? Negative 7I. Or you could say negative 7. Now, while you're doing that next one, well, if we go to the graphing calculator, so if I try to take the square root of a negative, non-real, oh heavens no, what do we do? Oh, well, guess what we do? Well, we're going to quit. No, we're not going to quit. But you're going to go into mode. And instead of real, we're now going to go into A plus BI mode. So under the mode, you choose A plus BI. This is going to be on video. Now, I'm going to quit out of this, and then I'm going to do the square root of negative 25 again. And there it is. There it is, my friends. There's the I. Pretty neat. Believe it or not, there are quite a lot you can do this. Like if you do the real part of 5 minus 7, now the I, you can hit second and period. Not the alpha I, That's different. But see, it gives you 5. And under complex, if we wanted the imaginary of 5 minus 7i, it's -7. So I mean, if you gave me -7 or -7i, that's how it works. You can actually find out magnitudes and angles, but that's a little bit above our need here. Basically, as a math major, I was required to take 3 semesters of calculus. And one of the courses I took as a senior was complex analysis. Basically, it was a rehash of calculus 1 through 3 with imaginary numbers. So that was big. That was a big course. That was a long one. That was a hard one. So the real part of this one is 3. The imaginary part is 2, or 2i. Now, we're going to look at what happens when complex numbers are added, subtracted, multiplied, and divided. Now, adding and subtracting is actually very, very simple. Because what happens here, if we distribute 3 plus 4i, well, we don't need to distribute here, but then we get 10 plus 4i. Combining like terms, we get 13 plus 8i. And believe it or not, you can actually do this in your calculator. And so you're probably thinking, why am I doing this if I'm just going to learn how to do it on the calculator? Well, it's unfortunately not going to be this easy. I shouldn't say easy. Look at that, 13 plus 8i. So I'm going to give you a minute to figure out those next 3. For this one, we get 12 minus 15i minus 12 minus 16i, and that's just going to be negative 31i, or 0 minus 31i. Now, it's true, yeah, you can do this on the calculator and get it done in one shot, but 16 minus 24i minus 15 plus 45i, that would be 1 plus 21i. Let's see, negative 7 times negative 4i, that is going to be positive 28i minus 6 minus 9i plus your 8. Let's see, negative 6 plus 8, that's 2. And that's plus 19i. So, yeah, adding and subtracting seems easy. Now, multiplying or dividing them is going to have a whole different dimension to this. This is where it's going to get progressively more interesting, I like to call that. So, if you go to the graphing calculator and just type in I, obviously you get I. Now, let's take that I and raise it to the second power. So I squared is what? Negative 1. Let's do that for I to the third. I to the third is negative I. How about I to the fourth? Just 1. Interesting. How's about I to the fifth? I. How about I to the sixth? I to the seventh? Negative I. Are we seeing something here? We're getting a pattern here. How about I to the 8th and I to the 9th? So, here's the thing. I know when I taught in Virginia, they would ask questions like I to the 275th power. Now, the thing is, it can only be I, -1, -I, or 1. So obviously, one thing you notice about powers of I, what's happening? Obviously, they're repeating. When does the cycle start up, restart? How many powers of I does a circle? Well, let's see. Remember, I is I. We have I, -1, -I, and 1. I, -1, -I, 1. Same thing. So basically, the pattern repeats how many how many powers? We should say after how many powers? 4 powers of I. Now, I'm not going to be asking you all these, but I want you to get it in your skulls that I squared is -1. That's going to be a biggie. What kind of numbers are even powers of I? Even powers of I. They're real. How about odd powers? They're imaginary. Yep. But, we're only going to be going up through I to the 2nd power with this in all reality. Because, well, that's just the way it is. If we were doing it by hand, we would be dividing by 4 and taking the remainder. But we're not even going to worry about that. You got to know 2 main things. This and this. SOL, that's the Virginia State Test. This is going to come in handy. Basically, memorize that idea that I squared is -1. Now, if we want to multiply complex numbers together, such as this, we could FOIL, and combining all the terms, we would get this. We're not done, though, because I squared is -1. So, yeah, it's not going to give you I squared, and here's the beautiful thing. 2 plus 3I times 5 minus 4I. (22 plus 7I). You can verify these with the calculator. Now, I want you to do these 3. Yeah, just use the calculator. I mean, I'm going to do it by hand, but that's because it's fun for me. My definition of fun is probably different, but yeah. So, I'm just going to do this one. I'm going to do all 3 of these by hand because, well, I think it's more fun to do it that way. So let's see. I get 6 minus 10I plus 24I minus 40I squared. That is 6 plus 14I minus 40. But instead of I squared, I would put -1. So that's 6 plus 14I plus 40, 46 plus 14i. Does it match what's on the calculator? Now, if you give me 14i plus 46, that's right. But I always do it as a plus bi. But if you want to be a rebel and do it 14i plus 46, I'm going to think, wow, yeah, this person is really got some guts to go against me. I'm kidding now. Pick your battles. That's all I can say. So for this next one, 35 minus 15i plus 7i minus 3i squared. That's 35 minus 8i minus 3, but instead of I squared, we get negative 1. 38 minus 8i. Is that right? Awesome. Now, here's something kind of cool about this. 16 plus 24i minus 24i minus 36i squared. The answer is 52. So, well, these first two had answers of the form a plus bi. What about that last one? The last one was the answer was complete, was pure what? Pure real. So, whenever you multiply two complex numbers that are of the form a plus bi and a minus bi, what you're doing is you're multiplying two complex conjugates. Now, think back to when I talked about, when we did quadratic equations that had radicals, like 3 plus 2 times the square root of 7. What was the conjugate of that? 3 minus 2 times the square root of 7. Basically, when you multiply two conjugates together, you get a pure real number. That's it. Case closed. Now, that's going to come into play when we relate our quadratic equations and whatnot. Now, if you do this, 6 minus 3i, quantity squared, well, let's see what happens. I'm just going to be, I don't want to call myself lazy, but I am just going to use the calculator. And we get 27 minus 36i. Basically, we would FOIL and get this. Now, you can do this in the calculator. In fact, let's do it in the calculator. That's why it's there. 4 minus I root 5. And to get past that, you just got to hit this button here, close up the parenthesis, 4 plus I root 5. Get past that and close the parenthesis on that, and we get 21. Basically, for all these quadratic equations that you ever do, basically, I use my calculator to come up with, I already have the solutions in mind. I use the calculator to get me the equation. So, with that in mind, what about dividing them? Now, similar to dealing with radicals, you have to multiply the numerator and denominator by the conjugate of the denominator. This is another form of rationalizing the denominator. And the reason we do this is simply because it's poor taste to have irrational or imaginary denominators. So, if I want to do this, We need to multiply the numerator and denominator by what? 5 minus 2i. Now, when you multiply both the numerator and denominator by the same thing, effectively you're multiplying by what? 1. Now, let's just use a calculator to do this. So the numerator, 4 minus 3i times 5 minus 2i. You get 14 minus 23i. Now, for the denominator, I think we get 29. Guess what? There's our answer. Now, you could write it as this. I would accept it either way. Now, 29 is a nice prime number that cannot be simplified any further. Whoops. All right, I want you to try the next two. Before I actually go over this next one, we can't do these in the calculator. First thing we got to do is set up the fraction. 4 minus 3i. Yep, it can be done on this. 5 plus 2i. And yeah, see, it splits it up like that. Now, if you did this, you multiplied the top by 8 plus 4i, and well, same thing with the bottom. You have 32 plus 16i over 80. Now, thing is, if I gave you one like this on a test, I will give you one like this on a test. Yeah, you're going to simplify. But truth be told, you probably could just do this on the calculator and I would accept it. But in other words, I'd be giving you a freebie. Almost. 32 over 80. What does 32 over 80 simplify to? 2/5 plus 1/5 I. Or you could do 2 plus I over 5. Either one works. So let's do that next one on the calculator because, well, 4 minus 3i. Believe me, you'll have your work cut out for you in this unit. (33 minus 31i over 82). I believe there are some of these on your MyLabs. I mean, yeah, truth be told, you can just punch it up on your calculator and go there. Where would we be without the graphing calculator? Well, I think we have a lot of trouble. Personally, yeah, I mean, a lot of teachers, old-timey teachers are like, those calculators are devil, tool of the devil. I completely disagree. Now, I've seen some people actually get like software where they can actually enter the equation that solves step by step for them. Don't do that. Because especially if I see multiple people doing the same thing, like, somebody did something on the calculator. Now, if we have only a pure imaginary, basically conventional wisdom would say multiply the top and bottom by -5i, But all you really have to do is multiply by I. You have 6I plus 3I squared over 5I squared. Well, that's negative 3 plus 6I over negative 5. Or 3 minus 6I over 5. Equivalent. Does it matter which one? No. I would prefer the second one myself, but you know, if it's right, it's right, you know. And let's do the same thing here. 4I minus 2I squared over negative 7I squared. Accept either one. All right, so don't worry, I'm going to put this right back. We're going to kind of open things up. So x squared minus 8x plus 25 equals 0. If you tried factoring this, it won't work. But we're going to use, let's complete the square for this. So if I'm going to complete the square, I'm going to move this 25 over here. Now, what value will I be adding to both sides so that I can complete the square? 16. Because remember, half of negative 8 is negative 4. Negative 4 squared is 16. Yeah, x minus 4 quantity squared equal to what? Negative 9. Oh, man. We've got our first equation with a negative here. Oh, no, no. Can't do that. Yeah, we can. So, we're going to have x minus 4 equal to plus or minus square root of negative 9 is 3i. So we get plus or minus 3i. Now, if I move this 4 over, basically we get 4 plus or minus 3i. Or you could write it as separate terms, 4 minus 3i, 4 plus 3i. Nonetheless, these two are what of each other? Conjugates. So I would accept, I don't want to write over the minus here. And you can actually type it on MyLab as plus minus. So that's how it's done. All right, I'm going to do a quadratic formula maybe. But could I have divided everything in the equation? I could have divided everything by 3. So if you're having some big numbers, and I believe that is 29, and that'll equal 0. Let's do the quadratic formula. So b squared minus 4ac. Well, that's negative 6 squared minus 4 times 1 times 29. And using the graphing calculator, we get negative 80. Well, the square root of negative 80, we need to break that apart. So that's going to take, so that's actually not so bad. Well, first off, I know it'll be I times the square root of 80. So two numbers that multiply to 80 are 2 and 40, 2 and 20, 2 and 10, 2 and 5. So basically we have I and 4 2's and a 5. And that'll become I times 2 times square root of 5, or 4I root 5. But we're not done yet, because we have to plug this in to the remainder of the quadratic formula. So it would be 6 plus or minus 4I root 5 over 2a. Well, that's just 2. So what we can do, we have 6 over 2 plus or minus 4I root 5 over 2. Well, 6 over 2 becomes what? And 4I root 5 over 2, this one, that 2 cancels, so plus or minus 2I root 5. All right. So that one is done. I'm going to give you what do you do? Should I complete the square or quadratic formula? All right, we're going to quadratic formula. So a equal to 9, b equal to negative 36, and c equal to 116. So we've got to do b squared minus 4ac first. Negative 36 squared minus 4 times 9 times 116. That is going to be negative 2,880. Now, again, I would not give you one that big on a test. Why? Because, well, frankly, you just don't have the time to deal with that. So, I'm going to just tell you what this is, negative 2880. A discriminant would not be any more than like 100 and something. This will be 24I root 5. I root 5. So, using the formula, it's negative b plus or minus the square root of the discriminant over 2a. Well, that's going to be 36 plus or minus 24I root 5 over 2 times a. Well, 2 times 9 is 18. So the 36 over 18 becomes a 2. I can divide by 6 here, plus or minus 4I root 5 over 3. And that's how it's solved. All right, so let's move this 114 over. And then we're going to complete the square. Half of 8 is 4. That squared is 16. So that is what we are going to be adding to both sides. So this will become x plus 4 quantity squared equal to negative 98. So, the fact that we have that, we're gonna have imaginary numbers. That's okay. So x plus 4 will equal plus or minus the square root of negative 98. Well, what we need to do is simplify this. So the square root of negative 98, obviously, we can take an I out. Now, what will that, square root of 98, what could we break that 98 into? About a 49 and a 2. So we get 7i root 2. So we just move that 4 over, and we get negative 4 plus or minus 7i root 2 for the two solutions. Now, we're going to come back to this idea here, but here's something I want you to do for me. Negative 4 plus 7i root 2 times negative 4 minus 7i root 2. Tell me what you get. And you can use the calculator. What do you get? $114. Where did we see that 114? And it's no coincidence. Basically, if you multiply the two roots, you get that. Now, and we're going to revisit this concept a little later. Now, negative 4 plus 7i root 2 plus negative 4 minus 7i root 2 is negative 8, the sum of the roots. Now, even though this is a positive 8, and that's a negative 8, that's another rule. We're going to come back to that idea. Probably that'll be in the next class. All right, so for this one, that's 16x squared plus 64x plus 109 equal to 0. Now, if we divide out everything by 16, here's the nice thing. We get x squared plus 4x, now plus 109 sixteenths equal to 0. So let's move that 109 sixteenths over to the other side. So in order for us to complete the square, half of 4 is 2. That squared is 4. So we get x plus 2 quantity squared equal to this. Well, negative 109 over 16ths plus 4, that's going to give us negative 45 sixteenths. So we're going to take the square root of both sides. Now, what happens here is when we take the square root of a fraction, take the square root of the numerator and the denominator. And in no case will I require you to rationalize a denominator. So basically what we get out of this is x equal to -2 plus or minus the square root of -45 over 16. Well, we've got to simplify that square root of -45. That's I times 45. That'll be I times root 9 and root 5. So it'll become 3I root 5. Oh, square root of 16 is 4. And that's what you get. All right, not bad. Not bad at all. All right, so we've graphed linear and absolute value equations on the Cartesian plane. Now, we learned how to do transformations with quadratics, but I didn't put that on the test because I said, well, we're going to be doing a hell of a lot more with it in the next unit. So I figured, well, save a little time. So we already know some of the basics about a quadratic graph. It is a U-shaped parabola. Now, some of the other things you should notice about the graph are that it is symmetric about the y-axis. So we're going to actually be able to determine various characteristics for quadratic equations, both graphically and algebraically. So domain and range, well, we already know how to do that. Zeros, x and y intercepts, line or axis of symmetry, intervals of increase and decrease, and end behavior. So the vertex of the quadratic graph is your minimum or maximum point. The x-intercepts of quadratic graph are where the graph crosses the x-axis, and they're also another name for zeros or roots. Now, remember how we really made the big connection with the absolute value equations in the graph? We're going to be doing all that for quadratics now. Now, if I wanted to find them algebraically, I would set y equal to 0. The y-intercept is where it crosses the y-axis. And you would set x equal to 0 to find that algebraically. Now, for the most part, you've seen a lot of this before. We're just going to dig a little deeper now with quadratics. Basically, if this were a 50-minute class, Unit 3 would be entirely about quadratics. Intervals of increase and decrease are written in interval notation and in terms of x. Now, there's only one interval of increase and one of decrease. Now, when we get into polynomials, that's going to change. However, the calculator is going to be our friend here. Basically, we're going to be able to get a lot of good information from certain characteristics of our quadratic. Domain is all reals. Range depends on what the vertex is. The line for axis of symmetry is a line that splits the graph into two equal parts. And it's the same thing with absolute value. And magically, the x-coordinate of the vertex is the same as the axis of symmetry. For example, if the vertex is 1, 4, then the axis of symmetry is the vertical line x equals 1. End behavior, what happens at the ends? What happens to y as x goes to negative infinity or goes to the left? What happens to y as x goes to positive infinity or to the right? Now, it looks like a lot. It really does. But we're actually going to see a lot of this basically goes hand in hand. So, for the parent quadratic, y equals x squared, the vertex is at 0, 0, and that's a minimum. X and y intercept at the origin. Interval of increase, that's from 0 to infinity. Decrease is from negative infinity to 0. Now the domain is all reals. Now the range, since that minimum is at 0, the range will go from 0 to infinity. Now the axis of symmetry is just x equals 0. Now, if you're freaking out, stop doing that. Because it's all going to work out here. You'll see. And for the end behavior, as x goes to both ends, y, you think it's going to go up or down? It'll go up. And as you'll see on number 6 on the first left, 6F, all you would have to do is circle one or the other. Now remember how we transformed equations. Guess what? It's all back. Except we are not going to do a horizontal structure shrink. We're not doing this, but you can do it. Now we can convert a quadratic equation from vertex form to standard form. So, for instance, this is vertex form. We're going to convert this to standard form. And all we would have to do is multiply those together, and then multiply it by 2, and then simplify. Then I'm going to show you a neat little trick that indicates that you've done it right. X squared minus 6x plus 9 minus 4. You have 2x squared minus 12x plus 18 minus 4. And that will be 2x squared minus 12x plus 14. Now, I want to show you kind of a neat way to see that, hey, you've done this right. Watch this. I'm going to go to y equals, and then I'm going to type 2 times x minus 3 quantity squared minus 4. Then I'm going to type in 2x squared minus 12x plus 14. I'm going to type all that in. And if you have a black and white calculator, which one of you does, now you can always borrow one of my color ones, you will see that, yeah, nothing would happen, but basically it draws over it. So that means they're equivalent. So we're going to work through this first one here. Now, basically the format of these, it's going to look like this, and then you'll be able to write this in vertex form. And as a matter of fact, I want to change that. I'm going to change that equation to something else real quick. We're going to change this to x squared minus 10x plus 24. All right. So here's what we're going to do. We're going to find the zeros first by setting that equal to 0. Well, we know this is going to factor into x minus 6 and x minus 4 equal to 0. So basically, we have x minus 6 equal to 0, x minus 4 equal to 0. So x will equal to 6 and x will equal to 4. Well, guess what? That is going to give us not only the solutions, but it will give us the 2 roots, 4 and 6. Now, let's graph that equation exactly how it's written. That's x squared minus 10x plus 24. And as you can see, right there. Now, I'm going to ask you to do this. I want you to find the average of the zeros. And I want you to find negative b over 2a. I want you to find both of those for me. The average of those 2 zeros, and we can set that equal to x. Basically, 6 plus 4 over 2, that's 10 over 2, or 5. Now, Negative b over 2a, well, what's negative b? Negative b is 10, and is divided by 2 times 1, which is 5. Now, x equals 5. Now, if you do it either way, you get the same thing. So I'm kind of spoiling this just a little. But if you now type in, if you go to the trace, we see that not only is it the average of the two zeros, but that is now the x-coordinate of the vertex. Now, I want you to find f of negative, not f of negative 5, f of 5. In fact, let me erase that positive. Why did I do that? If you find f of 5, well, that's 5 squared minus 10 times 5 plus 24. What is it? So guess what? The vertex is going to be at 5, negative 1. So there's our vertex. Guess what? You've been able to find, you just learned how to do vertex form without the calculator. Now, so the vertex is at 5, negative 1. Is it a max or a min? It is definitely a min. The x-intercepts slash roots slash zeros are at 4 and 6. Now, how about the y-intercept? It's at 24, or 0, 24. Now, we can't quite see it on here. How about the axis of symmetry? This would be x equal to 5. How about the range from negative 1 to infinity? Remember, since this is a minimum, and the smaller y value, it's at negative 1, it's got to be greater than that. Now, intervals of increase and decrease are written strictly in terms of x. It's going to increase from 5 to infinity and decrease from negative infinity to 5. So here's the thing. That vertex, the x-coordinate of the vertex, is telling us a crap load of things. The y-coordinate of the vertex tells us the range. Now, as x goes in both directions, where's y going? Positive or negative infinity? Positive infinity, and it's only going to be that way for now. Now, here is the big one. Let's write this in vertex form. Well, keep in mind the vertex is at 5, negative 1. So this would be x. Would it be plus or minus? Because it's moved to the right. And after that, it comes minus 1. Hey, guess what? X coordinate of the vertex, Y coordinate of the vertex. Boom. Now, if you're not sure, we can type it into the calculator and see if we get a match. Oh, that's not the same graph. Let's see, minus. There we go. So now that enables us to do the transformation. Well, guess what? That's easy. Was there a vertical stretch or shrink? Is there anything in front of this? Nope. No reflection. Horizontal shift to the right by 5 and down by 1. How did we get the vertex form? So basically, it's not a bunch of doing here. This part here talks about how did I get that? Well, completing the square would be method 1 to find the vertex. Now, method 2, you can find the roots and then find the x coordinate of the vertex by taking the average of the two. And then once you find the x coordinate of the vertex, plug it in and get the corresponding y coordinate. Now, we can also find the x coordinate of the vertex by doing negative b over 2a. Well, here's the thing. Negative b over 2a comes from what? Quadratic formula. So there are other ways to do this. I mean, yes, there's 3 ways. Method 2 and 3 are the easiest. Now, if we did this with something like this, completing the square becomes a major bear. But finding the average of the 2 solutions shows this. Basically, all this will show that you get the same thing. So actually, I'm going to change this equation. So what we can do now, our vertex is at 1, negative 4, and obviously it's going to be a minimum. And this is what the graph looks like. Now, how about the y-intercept? What's the y-intercept? Yep. Or you could write it as 0, negative 3. Now keep in mind, this vertex of 1, negative 4 is going to tell us a lot of things. How about axis of symmetry? X equals what? X equals 1. It's a vertical line. How about the range? Y is going to be greater than or equal to negative 4, or from negative 4 to infinity. Interval of increase goes from 1 to infinity, decreasing from negative infinity to 1. And as x goes off in both directions, y is simply going to go to positive infinity, which is up. Now, here is the million-dollar question. Well, can we write this in vertex form? Well, since there's nothing in front of the x squared, so this will be x plus or minus What do you think? Minus what? Correct. Minus 1 quantity squared. And after that comes what? Not the y-intercept, minus 4. So here's the thing. This vertex, the x-coordinate is 1. That tells us the axis of symmetry, intervals of increase and decrease, and the x-coordinate of the vertex. The y-coordinate of the vertex, which was negative 4, that tells us something about the range and the y-coordinate of the vertex. Now, if you enter this into the calculator as x minus 1 quantity squared minus 4, see how it just draws right over it? That's all there is to it. Now, as far as transformations go, was there a vertical stretch or shrink? There's nothing in front? No. No reflection. We had a horizontal shift to the right by 1 and down by 4. So that's how this is going to work. Now, for the next one, I'm actually going to change this 2x minus 15. I'm going to set that equal to 0. And this is going to factor into x minus 5 and x plus 3. Now, it might not easily factor in the future. The future ones might not factor. You might have to use the quadratic formula or complete the square. That is okay. So, if x minus 5 is 0, we get x equal to 5. X plus 3 equal to 0. X will equal negative 3. So, there's our zeros at 5 and negative 3. And you can even do this on the calculator. Now, the thing is, the zeros might not even appear on the calculator. They could be imaginary. All right. So, the x-coordinate of the vertex. And because I feel like it, I'm going to do it both ways. The average of the zeros. So that would be 5 plus negative 3 over 2. That's 2 over 2. X would equal 1. Or we could do negative b over 2a. That would be 2 over 1. So there's the x-coordinate of our vertex. F of 1, let's see, that's 1 squared minus 2 times 1 minus 15. It's going to be off the charts. Don't worry. Let's see, 1 minus 2 minus 15, that would be negative 16. Yep. So basically, our vertex is at 1, negative 16. Which technically it would be down here. X equals negative 3 and x equals 5. Here's the graph. Now, y-intercept is at 0, negative 15. The axis of symmetry is x equals what? 1. Now, the range is from negative 16 to infinity. Now, x squared minus 2x minus 15. Here's the thing. Now, I can change that window value. Don't zoom now. I'm going to change that line in to negative 20. So, yeah, here's 1, negative 16, negative 3, and 5. So the interval of increase, it's from 1 to infinity, negative infinity to 1. And as x goes off, y is going to go to positive infinity. And we would get x minus 1, 20 squared, minus 16. Well, let's just see if that works. Spoiler alert, it does. What? All right, what did I do here? I used the negative. And because of that negative there, that multiplied. I should have used a minus. People still do that. BEA, beautiful. So, no stretch, no reflection. We went right by 1 and down by 16. All right, so we're going to work on a boatload of these. I'm actually going to change the equation in probably all of these, so don't do these in advance. This evening. So to do this, we can just factor and get x minus 7, x plus 3 equaling 0. Now, let me give you a little word of caution. Not all quadratic equations will be easily factorable like this. If x minus 7 equal to 0 and x plus 3 equal to 0, x will equal 7, x will equal negative 3. So, I'm going to go back to that, don't worry. X squared minus 4x minus 21. Now, if we go to the graph, we see negative 3 and 7. We see that's where it's going to cross the axis. Now, problem is we don't see the y, we don't see the vertex very well. We're going to have to do a little maneuvering for that. So, for the vertex, I could do x equal to negative b over 2a, which would be 4 over 2, which is 2, or 7 plus negative 3 over 2, which gives me 2 that way. Either way, x equals 2 is the equation for the vertex. Well, no. Well, that's actually the axis of symmetry. If we do f of 2, that would be 2 squared minus 4 times 2 minus 21, and that would be negative 25. So the vertex would be at 2, negative 25. Problem is, the graph doesn't indicate that. Well, we can't show that on that graph. Every time, I always forget to change this. Basically, you're going to draw your own graph. But if we go to window, let's change that y min to negative 30. Do not zoom out, because if you do, it'll distort the x view. Perfect. And thing is, you'll basically, instead of that graph, I should have just covered that up or blanked it out. So we get 2 and negative 25, and obviously that's going to be a min. The x-intercepts are negative 3 and positive 7. And as you can tell, here they are. Now the y-intercept is 0, negative 21. The axis of symmetry, x equals 2. Now the range for this, now keep in mind this is to negative 25. So basically from negative 25 to infinity. The interval of increase goes from 2 to infinity, decreases from negative infinity to 2. And it's still going up in both directions. Y is going to go to positive infinity. And yeah, we can write this in vertex form. X minus 2 quantity squared minus 25. In fact, let's double check that. If we go and type in x minus 2 quantity squared minus 25, we get the same thing. So no, none of that. We went to the right by 2 and down by 25. All right, so that's going to do us for today, everyone. Thank you. And be safe. I heard it. I see it's raining. Chances are, if it has a leading term other than 1, you will be able to factor it. Now, you can solve this using whatever the heck methods you feel like doing. And I'm actually feeling a little squirrely. I'm going to use the quadratic formula. A is 3, B is 11, and C is negative 20. So we have to figure out what the discriminant is first. Minus 4 times 3 times negative 20. So 11 squared minus 4 times 3 times negative 20, it's going to be 361. So the square root of 361 is 19. So basically you have negative 11 plus or minus 19 over 2a. Well, 2a, that's 2 times 3, or 6. So we're going to get 2 solutions out of this. So negative 11 plus 19, that is 8 over 6, or 4 over 3. Negative 11 minus 19, that would be negative 30 over 6, or negative 5. So those are the 2 roots or zeros or whatever you want to call them. So 4/3 and negative 5. So here's negative 5, and 4/3 is 1 1/3. Now, and you can actually see if you graph this, you hit trace, 4/3 and negative 5 are in fact roots. Now, what we're going to do here is we're going to find the vertex. Now, the vertex, unfortunately, is not going to be a nice, clean number to deal with. So, what we'll do to find the vertex, well, first, which coordinate of the vertex do we have to find? We're always finding the x-coordinate of the vertex. That's the first one you find. So let's see. We could do negative b over 2a, which would be negative 11 over 6. Now, we could also do the average of the roots, if we want. So, 4/3 plus negative 5, and that's divided by 2. Or negative 5 plus, I could do it this way, 4/3 and then divided by 2 is negative 11/6. Here's the thing. You'll probably get one that has something like this. I will not accept a decimal for this. You have to give it to me exactly. But the good thing is your calculator will do just that. Now that we found the x-coordinate of the vertex, we need to find the y-coordinate of the vertex. So basically, we replace any and all x's with negative 11/6. And we're going to get a fraction for this. Actually, what I'm going to do is I will do this. Negative 11/6 quantity squared, make sure you square that, plus 11 times negative 11/6. And then minus the 20. And for that, we get negative 361/12. So the vertex is at negative 11/6 and negative 361/12. Now, for drawing purposes, I want to just get an approximation to this. So if I multiply this by 1.0, I get negative 30.08. Now, the purpose of doing that is simply so that I can graph it. So the vertex is definitely going to be off our chart here, unfortunately. So how do we deal with that? Well, we go to the window. Now, remember, the standard viewing window, to get the standard viewing window back on your calculator, it would be zoom and zoom 6, correct. Now, for this one, I know my y meant, it was negative 30 point something and change. Let's just do negative 35. Okay. Oh, y max. Well, that's y. So, yeah, negative 35, and then we'll make that 10. I mean, it really doesn't matter. But what happens here is we see the whole thing. So I'm actually going to copy this over to my notes right here in the picture. There it is. And what you can see is that there, the two roots are in fact at negative 5 and at 4/3. So the vertex is at negative 11/6, negative 361/12. Now, is this going to be a max or a min? This is going to be a minimum. Very good. Now, how's about the y-intercept? Negative 20. Basically, yeah, replace x with 0, and you could also do it here. Works. The axis of symmetry is x equal to what? Negative 11/6. Now the range, now remember the range, this vertex is going to tell us quite a bit. So the range will go from negative 361/12 all the way to infinity. Now the interval of increase is from negative 11/6 to infinity, decreasing from negative infinity to negative 11/6. Now, as x goes to positive and negative infinity, since it's going upward at the end, y is just going to go to infinity. Now, let me reiterate another thing. when you have that on a test or something, it'll just ask you to circle one of them. You actually don't have to write that out. Now, vertex form. So we have the vertex as x. Now, since that's a negative, we would do plus 11/6 squared minus 361/12. So let's double check that in the calculator. So x plus 11/6 quantity squared minus 361/12. Oh, did I forget something? It is positive. Well, the vertex, I forgot the 3. Ah. Now see, here's the neat thing. Yeah, this 3, whatever is in front of the x squared goes right in front of that with no problem. So let's put the 3 in front of that and see if that changes things. Ah, there we go. So, did we get a vertical stretch or a shrink or none? Correct. Because this is greater than 1, so it's a factor of 3. How about a reflection? No, no reflection. How about a horizontal shift? Which way? To the left by 11/6. You'll have more room. That gap is kind of small to write it, but, and again, I need that in exact form. And vertical shift, up or down, by 361/12. So that's how we do this here. It is not going to factor. So we're going to use completing the square. So x squared plus 6x will equal -7. And we've got to add something to both sides to complete the square. What's that going to be? Let's add 9. Now, if you did use the quadratic formula, it's not wrong. You know, I'm just doing it differently. And that's because I can. So for this, we would get x plus 3 quantity squared equaling 2. So the solutions for this are going to involve radicals. X plus 3 will equal plus or minus the square root of 2. So x will equal -3 plus or minus the square root of 2. You know, -3 plus root 2, -3 minus root 2. You could do it either way. But these two are what of each other? Conjugates. Good. So, you know, that's -3 plus root 2. Spoiler alert, I already know it's going to be a 0, see? But I entered it there because, well, that's where my graph needs to be. And see, I can't see as well here, so I'm going to blow that up just a little. And let's see. negative 3 minus root 2, negative 4.41. Okay. Or, we could write it as, negative 3 plus or minus root 2. Now, let's find the vertex. Let me get out of that. So, let's do x equal to negative b over 2a. Well, let's see. Negative b would be negative 6 over just 2, and that would be negative 3. What is the real part of those solutions, by the way? The fact that this and these are the same is no coincidence. Just so you know. The more you know. Now, if we do f of negative 3, that would be negative 3 squared plus 6 times negative 3 plus 7. Oh, well, guess what? I could actually just punch it here and get negative 2. So negative 3, negative 2 is my vertex. And are we dealing with a max or a min for this one? We're back to the mins. So here we are. And that's where it is. So the y-intercept is at 0, 7. The axis of symmetry is x equal to negative 3. The range goes from what to what? From negative 2 to infinity. So the interval of increase is from negative 3 to infinity, decreasing from negative infinity to negative 3. We're back to our original end behavior. As x goes to plus or minus infinity, where's y go? Infinity. Vertex form. In fact, let me zoom out now. I think I zoomed out too far. So it would be x plus 3 quantity squared minus 2. No stretch, no flexion. We go to the left by 3 and down by 2. All right. Slew of ways. Let me see. I have a hankering to complete the square. Now, you know what? I'm going to use the quadratic formula. So a is going to be negative 2. Keep this in mind. B is negative 5, and C is 3. So remember, the first thing when you do the quadratic formula, first thing you always got to figure out is the discriminant. B squared minus 4AC minus 4. 2 and then 3. So we get 49. And of course, the square root of 49 is in fact 7. So using the rest of the quadratic formula, we get 5 plus or minus 7 over negative 4. Now, why is this a positive 5? Negative, double negative. Yep. Watch yourself on that. I will give you the quadratic formula on this test again. So we get 12 over negative 4, which is in fact negative 3. We get negative 2 over negative 4, which is 1/2. And if we go to the graph, negative 3 and positive 1/2, we see them right there. So now let's figure out the vertex. So the vertex, yeah, we could do the vertex a whole slew of different ways. I'm only going to do it one way this time. X will be negative b over 2a. Well, the x-coordinate will be positive 5 over 2 times negative 2, and we get negative 5/4 for the x-coordinate. So there is the x-coordinate of the vertex. Now, f of negative 5/4 would be 2 times negative 5/4 squared minus 5 times negative 5/4 plus 3. Or here's something else we really could do. If we did negative 5 over 4, we get this. You could do it on your graph. Now, 6.125, I would be okay with this because what kind of a decimal is this? It terminates. However, I know, this is 6 1/8, or if I go to 6.125, math, enter twice, I get 49/8. So honestly, I would accept the decimal equivalence of this because of the fact that it is a terminating decimal. So let's see, negative 5/4 and 6.125 somewhere up here. So here's the deal. The vertex is at negative 5/4 and 49/8. Now, this is the first vertex where we actually have a what? A max. The intercepts, or roots or zeros, we get negative 3 and 1/2. Y-intercept is at 0, 3. Axis of symmetry, negative 5 over 4. Now, we're used to putting, for the range, we're used to putting the y-coordinate first. But that y value for the range is where the range is going to end this time. Negative infinity to 49/8. And again, I would have accepted decimal equivalence. And I just moved over here. I don't stand in this corner enough. Actually, it's a nice view. Interval of increase, well, it's from negative infinity to negative 5/4. And decreasing from negative 5/4 to infinity. Now, the end behavior is going to be a little different. X goes to positive or negative infinity. Where's y going this time? down, negative infinity. Now, can we write this in vertex form? So we would have x plus 5/4 squared plus 49/8. Did I forget something? Ah, you got to put that -2 in front. And just for a lark, let's see that it is the right one. Spoiler alert, it really is, but. No. What did I do? I forgot to square. Good. You're on your toes here. Like a midget at a urinal, you're standing on your toes. There. Let's see if this does it. All right, yeah. So now, to discuss the transformations, do we have a vertical, stretch, or a shrink? By a factor of 2, or I would accept -2. But the fact is, that's because this is also is there a reflection? Over what axis? Over the x-axis. We get the horizontal shift to the left by 5/4 units and up by 6.125. Notice that I'm mixing decimals and fractions here. That should just basically make it a point that if the decimal terminates, you can do whatever. All right, so that's that. All right, so we're going to move this 13 over. Let's complete the square. So adding 1 to both sides of this sucker, we get x minus 1 quantity squared equal to -12. So that's one reason why we don't really see anything, because we know the solutions are going to be imaginary. So we need to break apart this square root of -12. Well, first off, let's take the I out. We get I times the square root of 12. Well, I do know that 12 is 4 and 3, so we get 2i root 3, plus or minus 2i root 3. So x will equal 1 plus or minus 2i root 3. So here's the thing. This is not going to cross the x-axis. And this is purely y. Now, all I would need is this, but I'm going to add the fact that it does not cross the x-axis because they are imaginary. So they're imaginary. Now, we're going to find the vertex. X will equal -b over 2a. Well, that will be 2 over 2, which is 1. But again, real part, real part. You could just do it that way. I mean, yeah, you can recognize. So let's figure out f of 1. 1 squared minus 2 times 1 plus 13, that would be 12. So the vertex is at 112. It's not even on our graph. And no, you're not hallucinating, you're not imagining something. So, now if you zoom 6, get the standard viewing window, yeah, you won't see anything. But if you go to the window, let's make that Y max, I don't know, 20. Oh, not that. Yep. Way off Broadway. Now, this vertex of 112 is, in fact, a minimum. The fact that it doesn't cross the x-axis doesn't change any of these things. You know, the y-intercept is at 0, 13. Axis of symmetry is still x equal to 1. Now, the range goes from 12 to infinity. Intervals of increase and decrease. Yeah, see, nothing changes. It's just that it doesn't cross the axis. And this would be x plus, not plus, minus 1 quantity squared plus 12. So, yeah, really not a whole lot with this. Just a couple of moves. We went to the right by 1, and we went up by 12. Let's go ahead and, well, first, x squared minus 4x plus 7. Oh, by the way, zoom 6 takes you to the standard window. So let's see, x squared minus 4x. And I believe it was plus 7. And no, you're not seeing things. This is not going to cross the x-axis. But there are still going to be x-intercepts here. Well, first thing we need to do is take this x squared minus 4x plus 7 and set that equal to 0. So you have x squared minus 4x equal to negative 7. Let's complete the square on this. So we'll add 4 to both sides. So you'd have x minus 2 quantity squared equal to negative 3. Now, what's going to happen here is we're going to end up taking the square root of a negative here. Now, since this negative 3 can't get, obviously that 3 can't get broken apart anymore, you have x minus 2 equal to plus or minus the square root of negative 3. Or simply plus or minus I times the square root of 3. Well, let's just move that 2 over, and we'll get x equal to 2 plus or minus I root 3. So these are both conjugates of each other. Now, you don't have, and since these are, complex or imaginary, 2 plus or minus I root 3. Now, you don't have to write this down, but since these are imaginary roots, means the graph will not cross the x-axis. You don't have to write this down, but I just want to kind of give you that blurb. Now, we can find the x-coordinate of the vertex. Now, let's take the average of the roots. So 2 plus I root 3 plus 2 minus I root 3 entirely over 2. The I root 3's are gone, so we have 4 over 2, which is 2. But again, it is no coincidence that this and this give us, get the same thing. So now, if we find out what f of 2 is, which is 2 squared minus 4 times 2 plus 7, let's see, that would be 3. As a matter of fact, I want to point this part out here. X minus 2 quantity squared equal to negative 3. If we move this 3 over, we have the vertex form. So that's another way to see it. You don't have to do it that way, but it's just another cool way, in my opinion. So 2, 3 is the vertex. Now, and obviously it's going to be a minimum. Now, the y-intercept is 0, 7, or just 7. Basically, yeah, this graph is not going to cross the x-axis. So even though it has no real solutions. So one of your other questions on the test, your other quadratic bonanza problem will look like this. It'll have imaginary solutions. This, okay, here's the thing. We already know that it's symmetric about the line x equals 2. Now we know the y-intercept was at 0, 7, right? So symmetrically, I was able to just draw another point. Or if you remember you go over 1, up 1. So I could have drawn a better graph if I had done this. Maybe I will erase this graph and draw something a little better. Yeah. That's a little better. So yeah, the fact that I know that this is my axis of symmetry and that's the y-intercept, that's got to be a point as well. Or I could remember the 1, 3, 5 deal. So really, all this other stuff is not bothered by the fact that we had imaginary solutions. Because, frankly, yeah, we found those. So the range is going to go from 3 to infinity, interval of increase from 2 to infinity, and decreasing from negative infinity to 2. Our ends, goes up to just positive infinity. And for the vertex form, well, guess what? X minus 2 quantity squared plus 3. Now, if you weren't sure, you could always do this. X minus 2 quantity squared plus 3. Purely overlap. Boom, you got it. So, none of this, just a shift to the right by 2 and up by 3. Really, I mean, yeah, there's nothing much to this. All right. I'm going to give you one that's just a little more fun for your last one of these. I'm going to use the quadratic formula here. So if we do 4 squared minus, b squared minus 4 AC we get negative 100. Now, the square root of negative 100, it's just 10i. So, using the rest of the quadratic formula, you have negative 4 plus or minus 10i over negative 2. And what we can do is we could actually split this up, negative 4 over negative 2 plus or minus 10i over negative 2. It really doesn't matter if we wrote this as plus or minus 5i, plus or minus either 5i or negative 5i. The answers are going to be the same. So you'll have 2 plus or minus 5i. So if you try graphing this, you'd probably see that it doesn't cross the x-axis anywhere. So let's do the vertex. Well, I can already tell you what the x-coordinate of the vertex is going to be. It's just going to be 2. Negative b over 2 times negative 1, yeah. So let's see, negative 2, plus 4 times 2 minus 29. Yep, negative 25. So, well, let's graph this, by the way. That was negative x squared plus 4x minus 29. So, if I zoom 6 this here, we're not going to see anything. And remember, only putts with the y min and y max values. Don't ever zoom out. So let's try negative 40. You just have to keep putzing with it until you find something. So here it is. So the vertex, is at 2, negative 25. And is this one going to be a max or a min? This one is going to be a max. Now the x-intercepts or roots are zeros, 2 plus or minus 5i. And yeah, they're imaginary, they don't cross the axis. Y-intercept is what? 0, negative 29, or negative 29. Axis of symmetry, x equals 2. Now the range will go from negative infinity to negative 25. Now the interval of increase, negative infinity to 2, and 2 to infinity. As x goes from positive to positive negative infinity, y is going to negative infinity. And in vertex form, yes, we can. This will be x minus 25, but Negative or -1. Don't forget that. Now, one thing I am going to do, by the way, I'm actually going to put this I'm going to put a blank one of these as a separate sheet on Moodle under the notes, because there is going to be a whole bunch more examples, a whole bunch more different examples in my other class. So did we have a vertical stretch or shrink? Nope. How about a reflection? Over which axis? How about a horizontal shift? Which way? Right by and down by 25. All right. So, all right, let's go ahead and do this. So I'm going to use the quadratic formula. So A will be 4, B will be -8, and C will be 7. Seven. We get -48. Oh, we've got a negative here. So we got to break apart the square root of -48. So I'm going to do that kind of up here. So the square root of -48, well, first off, I can take an I out of that and get I times the square root of 48. Now, you could break down 48 into a direct product of primes, or what you could do is, if you recognize that 48 breaks down, 16 is a factor. So if 16 is a factor, we would get 4i root 3. So that's what we would get when we break that apart. So if we punch up the rest of the quadratic formula, we will get, since b was -8, we'll have 8 plus or minus 4i root 3 over 2a. Well, that's 8. So we'll do 8 over 8 plus or minus 4i root 3 over 8. So 8 over 8 is 1. This 4 and this 8 simplify. So you have plus or minus I root 3 over 2. So there's your solutions. Now, believe it or not, the x-coordinate of the vertex, this one actually, x-coordinate of the vertex, well, we can already tell it's 1. But if I do negative b over 2a, just for fun, that would be 8 over 8, which is 1. So I just wasted 7.2 seconds in doing that, but oh well. When you can see multiple ways of getting the same solution, you feel more confident about yourself. So f of 1 would be, next to this. Let's enter this on the graph. So 4x squared minus 8x plus 7. So so when we do this, it's going to be at 1, 3. So our vertex is at 1, 3, and it's going to be a minimum, and the x-intercepts / roots / zeros are 1 plus or minus I root 3 over 2. So now if I plot that minimum of 1, 3, now the y-intercept, what's our y-intercept going to be? It's going to be at 7. So here's the thing. My axis of symmetry is x equal to 1. So automatically, I actually know that if that's 7, that's going to be 7. And it'll look just like that. So 1, 3. So the range is going to go from 3 to infinity, increasing from 1 to infinity, decreasing from negative infinity to 1. Yeah, the end behavior, same story. And it would be 4 times x minus 1 quantity squared plus 3. So because of the 4 that is outside of that, we're going to have a vertical stretch by a factor of 4. No deflection, but we are going to be able to shift it to the right by 1 and up by 3. So yeah, that vertex tells you basically everything you need to know about a quadratic equation. So what will happen here is, so I'm going to use the quadratic formula. Now, you don't have to memorize it because I am going to give it to you on the test. Now, for the quadratic formula, if you're going to do this with the quadratic formula, what is the first thing you find? The discriminant, which is b squared minus 4ac. So that's going to be 3 squared minus 4 times negative 2 times 5. And in using the calculator, we get 49. So the square root of 49 will then equal 7. So if we go about the rest of the quadratic formula, which is negative b, so negative 3 plus or minus 7 over 2 times negative 2, well, you're going to get two solutions out of this. Negative 3 plus 7 is 4, 4 over negative 4, which is negative 1. Negative 3 minus 7, it's negative 10 over negative 4, which happens to be 5/2. So negative 1 and positive 5/2 are the two roots. And here's the graph of it, so you can tell. So x equals negative 1 and x equals 5/2. That's one way I would accept it. I would also accept it that embraces like this. Or negative 1, 0 and 5/2, 0. But the one that I will not accept would be like negative 1 and 5/2 is an ordered pair, because that's implying ordered pair. So, yeah, there are many ways I would accept it, but there's one way I really want. All right, vertex. So let's do negative b over 2a. And here's the thing. So that'll be negative 3 over 2 times negative 2. So this becomes 3/4. Now, I would, since 3/4, what kind of a decimal does 3/4 give you? 0.75, or a terminating decimal. I would accept this like that. I would accept it as a terminating decimal. The previous one is where the vertex would have a repeating decimal. I would not accept that. In fact, yeah, the problem that's on your test is going to start off with a 3x squared. I'm just telling you. So you have to know your fractions. So we need to find out f of 3/4. Well, that would be negative 2 times 3/4 squared plus 3 times 3/4 plus 5. And let's see what we get. We get 6.125, and I would accept that, or we could call it 49/8. So, 3/4, 49/8, or 0.75, 6.125. And you would only be able to do this if this was a terminating decimal, like this. So I'm going to keep it as a fraction because, well, I like it that way. So 3/4 and 49/8, so which is right about here and here. Perfect. All right, so now we're able to figure out a few things such as the y-intercept. What's the y-intercept going to be? Yeah, or I would accept 0, 5. Axis of symmetry, 3/4. Remember, I always like to think of this. Axis of symmetry, x-coordinate of the vertex. Now the range is going to be different. It used to be that the range would start off with whenever it was a minimum. Oh, by the way, this is a max. If it were a minimum, it would start. But since it's a max, we're actually going to start with negative infinity and go all the way to 49/8. And for range of a quadratic like this, it has to be in brackets. I mean, the other value has to be a bracket. I will ding you a little if you make that a parenthesis. Not brutally, but. So interval of increase and decrease, it's increasing from negative infinity to 3/4, and then from 3/4 to infinity, it's decreasing. Now, let me also tell you, when you see this on a test, you're not going to have to write out the end behavior. I'm just going to say circle one. You're either going to circle as y go, y will either go to positive or negative infinity. But where will y go here? Negative infinity. It goes down. And can you write this in vertex form? Yes, you can. It would be x. Well, wait, what was in front of the x squared? Negative 2. So will it be plus or minus 3/4? Remember, it was positive 3/4. Move to the right. Horizontal behaviors are opposite. Gotta watch that. Now, if you actually gave me plus, I mean, I would obviously ding you, but not brutally. But you can always do this. Yeah. If we did x plus 0.75 squared plus 6.125. So yeah, that tells you that, okay, you didn't put that in right. All it matters is a horizontal shift, and there it is. So, did we have a vertical stretch for this or a shrink? It's a stretch by what factor? It's a stretch by a factor of 2. Did we have a reflection? Over which axis? And we shifted to the right by 3/4 and up by 49/8 units. So I'm going to complete the square for this one. So x squared minus 2x will equal 11. So half of -2 is -1. That squared is 1. So basically, we are going to get x minus 1 quantity squared equal to 12. So we're going to take the square root of both sides. Now, we need to simplify the square root of 12. Well, it's just square root of 4 and square root of 3, which becomes 2 root 3. So basically, x minus 1 will now equal plus or minus 2 root 3. And we just move that 1 over, so we get 1 plus or minus 2 root 3. Now, if we go to graph this, which is here, now we can't quite see the y-coordinate of the vertex. We're going to have to put some window values in just a couple of minutes. But let's figure out the vertex. X would equal -b over 2a, and that would be 2 over 2, which is 1. Now, here's something very interesting. The x-coordinate for the vertex was 1. What was the real part of this? They're the same thing. That's not a coincidence either. That will happen. That would happen. So theoretically, you could actually get the x-coordinate of the vertex that way. Now, f of 1, 1 squared minus 2 times 1 minus 11, let's see, -12. So 1 -12 is the vertex. Now, x will equal 1 plus or minus, what was it, 2 root 3. You can write it this way, or you could write them individually. It's easier to write it with a plus minus. And the vertex is at 1 -12. Now, if I go to my window values, we're never going to want to zoom out. Never zoom out. We just want to only change any ymin and ymax values. Let's change this ymin to -15. See? And if we go to trace, 1 -12. Now, the good thing is the 1 -12 would be right about here. Now, 1 plus and 1 minus 2 root 3, see, those are what we call irrational zeros. By the way, those two are what of each other? conjugates. Now, if I'm on the trace and I do 1 minus 2 root 3, it's negative 2.46 and change, but this is where it's going to be. And that was 1 minus 2 root 3, I believe. And then 1 plus 2 root 3 will be 4.46, right about here. And y-intercept is negative 11, so basically we have everything we need to do to draw our graph. Oh, yeah. There we go. So y-intercept will be 0 and negative 11. Axis of symmetry will be x equal to what? X equal to 1. Now, if you draw that, looks just like this. How about the range? Negative 12 to infinity. How about the interval of increase? One to infinity, and negative infinity to 1 for the interval of decrease. All right, I see you there, Kenzie. As x goes off in both directions, y is going to go to infinity. And we can write this in vertex form, x minus 1 quantity squared minus 12. So basically, the fact that the solutions, or the x-intercepts, were in fact irrational. Now, you would be expected to give them to me in simplest radical form. Now, the one that's on your test, yeah, one will be radicals. You'll be expected to do that. I don't want decimal approximations. That's not going to fly. So, since there was nothing in front of that, no vertical stretch or nothing, no reflection. So basically, this vertex form is just telling us what we can do. So we go to the right by 1 and down by 12. So yeah, the purpose of writing this in vertex form would help you be able to get the transformations a little bit easier. All right, so that's going to be that one. So we'll go ahead and solve this. So the first thing we need to do is we need to solve this. Now, we could solve this any method we so desire, whether it's factoring. FYI, if the leading term is something other than 1, chances are it's going to be a factorable one. Well, it would be on your test. There is one towards the end of this that it won't be factorable, but I wouldn't give one that brutal on a test. So, I don't know. I think I'm actually going to complete the square for this. So, whether you complete the square or quadratic formula or whatever, in reality, I mean, it doesn't matter. So you have x squared minus 7/3 x minus 2 equaling 0. But we have to move this 2 over to the other side. Now, we have to figure out what it is that we're going to add to both sides. Well, 1/2 of negative 7/3 is negative 7/6. And negative 7/6 squared is 49/36. So here we would have x minus 7/6 quantity squared equal to whatever 2 plus 49/36 is. Well, 2 plus, we just used a calculator, 49 out of 36. That's going to be 121 out of 36. So we take the square root of both sides. X minus 7/6 will equal plus or minus the square root of 121/36. Well, nice thing here is 121 and 36 are both perfect squares. And that's going to be 11/6. So basically, x minus 7/6 will equal plus or minus 11/6. So we get two equations out of this. X minus 7/6 equals 11/6. X minus 7/6 equals negative 11/6. So in this case, x would be 18/6 or 3. And in this case, x would be negative 4/6, which is negative 2/3. That sounds right, yeah. Now, so we have the roots of x equals 3 and x equals negative 2/3. Now, one thing you can do is graph this. So this was 3x squared minus 7x minus 6. Minus 6. And we see negative 2/3 and positive 3 are in fact the two roots. So we have that in there. Now we're going to be able to figure out what the vertex is. So finding the vertex, well, we can do either negative b over 2a, or we could do the average of the two roots. But you're going to find something very interesting here in just a minute. So if we do negative b over 2a, well, let's see, negative of negative 7 is positive 7 over 2 times 3. That's going to be 7/6. Now, interestingly, we completed the square and got this. That's no coincidence, FYI. Now, we need to find the corresponding y value. So f of 7/6 means we replace every x with 7/6. And since this is, since these decimals do not terminate, you're going to need to give these answers as fractions, I'm afraid. Well, the fractions shouldn't really scare you because your calculator does them very easily. And we get negative 121/12. So that means the vertex is simply at 7/6 and negative 121/12. So negative 121 over 12 is just a little bit smaller than negative 10. But fortunately, in the graph that I gave you, we don't, that's not going to freak us out too much here. But we have all the information that we need. 7/6 and negative 121 twelfths. Now, if we draw the x-intercepts, which are here and here, 7/6. So basically, the vertex is going to be right here. So would this one be a maximum or a minimum? This is a minimum. Pretty soon, we're going to deal with ones that have a maximum. Now, how about the y-intercept? Yep. Or you could say it as 0, -6. Now, if you want to, just type in, go to trace and type in 0 and you get that. I would accept either one. Yep, either this or this. I would accept either one. Axis of symmetry is x equal to what? Seven over 6. Remember, it's the x-coordinate of the vertex. Now, the range, well, the minimum y value is negative 121 twelfths. So basically, we have negative 121 twelfths all the way up through infinity. Now, interval of increase, now remember, that's written in terms of the x-coordinates. So here's our vertex. It's increasing to the right of that, so 7/6 to infinity, and then negative infinity to 7/6. Now, for the end behavior, as x goes off in both directions, where's y going? Up, positive infinity. Now, let me just tell you before we finish this that you'll have 2 of these quadratic breakdowns on your test. One will have imaginary solutions and the other will be more or less something like this. I'm in the process of writing your test. So, yeah. Now, vertex form, well, that would be x minus 7/6 quantity squared minus 121 twelfths. Now, let's verify that that works. Oops. There we go. Minus 121 over 12. Oh, wait a second. I forgot to put something in front of that. What do you think is going to go in front of it? A 3. And here's the thing. The 3 that was in front, whatever is in front of that x squared, is going to go in front of the vertex form. Never deviating from that. So let me change that up a little, and let's put the 3 in front of it. Let's see what we get. And magically, we get exactly the same thing. So, did we have a vertical stretch or shrink? By what factor? Correct. How about a reflection? Nope. Horizontal shift. Which way? 5. Now, the one that's on your test, you'll have more room for this. And we did get a vertical shift, up or down, by 121/12. All right, not bad at all. To look at writing quadratic equations. So, let's say we want to create a quadratic equation given the roots. All we have to do is convert them to factors and multiply them. So what we have to do is simply convert each of these to factors. So to do that, for the x equals 3, we're going to subtract 3 from both sides. So we have x minus 3 equals 0. And that means x minus 3 is the factor. Now, if x is equal to -5, we need to do what to both sides? We're going to add 5. Basically, to convert them to factors, you make the other side 0. Now we have our two factors. So we do x minus 3 times x plus 5, and you get x squared minus 3x plus 5x minus 15, or x squared plus 2x minus 15. Now, if you were to graph this particular equation, you would see that those are the roots. Or if you were to use the polynomial root finder, you'll find exactly the same thing. So that's how that works. Real simple. Now, what if I were to throw in a condition that the equation has to pass through the point 8, negative 260, or that f of 8 is negative 260? Basically, we're saying the same thing here. So we would put a constant, we'll use any variable, and then plug in the x value of 8. So we can do this actually two different ways. A times x squared plus 2x minus 15 equals negative 260, but we're going to replace the x's with 8. So we figured out what is in front of that a. 8 squared plus 2 times 8 minus 15, which is 65. So a times 65 equals negative 260. So what does a equal? Negative 4. Now, what happens is we multiply it out. Negative 4 times x squared plus 2x minus 15, and all we get is negative 4x squared minus 8x plus 60. So basically part 1 is coming up with the most basic equation that you can from the two roots. Part 2 would be this, if there is a part 2. Now, you'll be doing this with polynomials. Now, for quadratics, for a polynomial, I generally will not do the third part. I mean, part 2 for polynomials. That's more factors. Now, here's the thing. If we were to type in, the original equation, which was x squared plus 2x minus 15, and then negative 4x squared minus 8x plus 60, and I'm going to zoom 6. Now, see, they do go through the same points. They have the same roots. Now, if I were to type in 8, that's 65, but if I were to type in 8 for that one, I get negative 260. So in other words, my work is good. Now, we're going to work through this next one together. Actually, yeah, let's work through this one together. We have x equal to 2/3 and x equal to negative 3/5. So the first thing we must do is figure out the equation that contains these. Now, I will have it written in your, I should have it written that we want the coefficients to be integers. So we need to get rid of the fraction. So for this first one, what can I multiply both sides by? For this first factor? 3. So now I am at 3x equal to 2. And then I'll just go ahead and subtract 2 from both sides, and I will get the factor of 3x minus 2. Now, what about this one? What do I need to multiply both sides of it by? 5. So I am now going to be at 5x equal to negative 3. What can I do to both sides here? We're going to add the 3. And so basically, we get 5x plus 3 equal to 0. So there's our two factors. 3x minus 2 and 5x plus 3. You can FOIL them or make a grid, whatever method you feel more comfortable with. But keep in mind, that would be 15x squared minus 10x plus 9x minus 6, or 15x squared minus x minus 6. So this was part A, identifying the equation. Now, part B is going to be that we include the rule. And this rule simply says that f of 4 equals 1150. So basically, I'll use that. You know what? Let me see. I'm going to use M. 15 times 4 squared minus 4 minus 6 equal to 1150. Yeah, I can use any letter. And I get M times 230 equal to 1150, or 230M equal to 1150. So, now by the way, this multiplier will always be an integer. So, if you were doing this and didn't get an integer, it's wrong. So, if we divide both sides by 230, what's M going to be? M is going to be 5. Now that we have that, the final answer, we just multiply 5 by this. We get 75x squared minus 5x minus 30. And that's it. All right, so we'll have x equal to 5 and x equal to 2/3. Well, this one's easy. All we do is take away 5, and we get x minus 5 equal to 0. Now for this one, I need to multiply out both sides by 3. So I get 3x equal to 2, or basically 3x minus 2 equal to 0. So we multiply those two suckers out, x minus 5 and 3x minus 2. So that would be 3x squared minus 15x minus 2x plus 10, or 3x squared minus 17x plus 10. Now, the thing is, let me point out something else here. If you could have gone straight from this to this, cool. I'm just showing all this. I'm showing more steps because, well, that's just the way I am. It's obvious that we have two roots. 7 plus 3 root 5 and 7 minus 3 root 5. Now, we need to get everything over to one side, so we'll take away 7 and 3 root 5 from both sides of this one. So we get x minus 7 minus 3 root 5 equals 0. And if we move everything over on this one, you would get x minus 7 plus 3 root 5 equal to 0. In other words, there's only one difference, the sign here. Because these two are what of each other? Conjugates. Now, I wouldn't like foiling this because, well, this is a 3 by 3. So we're going to make a table or a grid. So x minus 7 minus 3 root 5. X minus 7 plus 3 root 5. Now, what's going to happen here is we're going to get a bunch of cancellations. when this is all said and done. So x times x is x squared. X times -7, -7x. And we would get -3x root 5 for this, but don't worry right now because we're going to see something with this in a minute. We get -7x, positive 49, positive 21 root 5. For this, we would get 3x root 5. Now, 3x root 5 and -3x root 5 just cancel out. And -7 times 3 root 5, that is -21 root 5. So, yeah, we get some cancellations here. In other words, everything that is not rational is going to be gone. So 3 times -3, that would be 9, or -9, times root 5 times root 5 is just 5, or -45. So what we can do with this, we would write this out, x squared minus 14x plus 4. Now, that's one way to do this. Now, there is another way to do this. I want you to tell me what 7 plus 3 root 5 times 7 minus 3 root 5 equals using your calculator. Or by hand, it don't matter. Equals 4. Where have we seen that 4 before? The constant term. So basically, you could do it this long way, and there's nothing wrong with this. But if you did the product of the roots, it is equal to the constant term. Now, let's add these roots. Not take the average of them, but add them together. And tell me what you get. You get 14. Now, that 14, that's positive 14 here. Now this is negative 14. But basically, you take, this is obviously the sum of the roots. And basically, it is the opposite, or the additive inverse of the middle term. So you can do this a little more lickety-split if you did, if you knew that rule, or you could do it this way. Now, we're going to be doing the same thing. So here's the thing. We want to get these as two separate factors. x will equal -5 plus 4 root 7. X will also equal -5 minus 4 root 7. So, using method 1, we're going to convert these two into factors. So in other words, we're going to get everything on one side. So basically for this one, we would add 5 and subtract 4 root 7. So yeah, plus 5 minus 4 root 7 plus 5 minus 4 root 7. So basically, we get x plus 5 minus 4 root 7 equal to 0. Now, I'm going to put that in a parenthesis for obvious reasons. That's going to be a factor. Now, for this one, we're going to add 5 and 4 root 7. So basically, we get x plus 5 plus 4 root 7 equal to 0. So within the two factors, there's only one difference. What's the difference? Yeah, just here. So this is where it's going to get a little more fun. Now, FOIL would ordinarily mean we would multiply, first outer, inner, last. However, we don't have that luxury because there's 3 parts. So we're going to make the grid. Now, what you will find out here is you'll get some additive inverses in there, which will basically enable us to offset one another. So, x times x is simply x squared. 5 times x is 5x. X times -4 root 7 is -4x root 7, or you could do -x4 root 7. It's not going to make a difference in 42 seconds. X times 5 is 5x. 5 times 5 is 25. 5 times -4 root 7 is -20 root 7. 4 root 7 times x is 4x root 7. 5 times 4 root 7 is positive 20 root 7. So, as I said, these are gone, and so are these. However, we do have to simplify that last part, which, multiply wholes by wholes, so that would be -16 times square root of 49. Well, that is -16 times 7. 16 times 7, that would be -112. So, combining all like terms, we would get x squared plus 10x, 25 minus 112, -87. So, that there is method 1 on how to do that. Yeah, because 25 minus 112 is negative 87. Now, we're going to take a second approach here. These were the roots. I want you to do negative 5 plus 4 root 7 times negative 5 minus 4 root 7. And you can just do that in your calculator. And you're going to tell me what that'll give you. Guess what? Where did we see that before? So, if you memorize the concept that the product of the roots, so basically the product of the roots is going to be equal to the constant term. Now, I want you to, so we're going to do the sum of the roots. Negative 5 plus 4 root 7 plus negative 5 minus 4 root 7. So the sum is going to be a lot quicker. What is the sum of these two roots? Negative 10. What was the middle or linear term of our product? It was positive 10. So basically what you'd have to do here, take the additive inverse or opposite, take the opposite of the sum for the middle term. So, whoops. So in other words, you could do this either method. And we are going to get into some more practice with that next time. I don't think we'll have enough time to go to get the next one off. So all right, so the first thing we need to do is find some zeros here. So we'll use the calculator. It's x to the third minus 14 x to the second plus 49x minus 8. So when we go to do that, we see that we have only one 0 that is rational. So basically, if x equals 8 is a 0, now what we need to do is divide by x minus 8. So basically, we put that in here. So 8 times 1, that's 8. That'll be negative 6. That will be negative 48. That'll be a 1. And that'll be 8. And that'll be 0. So x squared minus 6x plus 1 is going to equal 0. So then, unfortunately from this, well, not unfortunately, but we are going to get some irrational roots from this one. So, x squared minus 6x plus 1 equaling 0. X squared minus 6x, that'll equal negative 1. Let's complete the square on this. Half of negative 6 is negative 3, and that squared is 9. So that's what you're going to add to both sides. You'll have x minus 3 quantity squared equal to 8. So we take the square root of both sides. X will equal, actually no, let me dial back a little. X minus 3 will equal plus or minus 2 root 2. X will equal 3 plus or minus 2 root 2. That's what you're going to get. So what we're going to do now is put those on a number line in order and see what happens. Now, you might be a little confused, now wait, where did these come from? Well, let's take a look here at the graph. Now, 3 minus 2 root 2, that appears to be our first root. So that's 3 minus 2 root 2, or I'll call that A. And the next root, well, let's see where 3 plus 2 root 2 is. Oh, it's going to be our second one, which, we'll call B. And for the last one, which was 8. So basically, you have your x minus A, x minus B, and then x minus 8, or you could call it C. It really doesn't matter, because basically the scheme of the signs, this is 3 negatives, positive, negative, and then positive. Now, which one did I want? I want the positive ones. So, the answer in brackets, it will be 3 minus 2 root 2 to 3 plus 2 root 2, bracket, union with 8 to infinity. I'm going to change the same thing. So you're going to have 6x to the 4th plus x to the 3rd minus 53x squared plus 15x plus 63 equals 0. So we've got to find 2 of the zeros, 2 of those. So let's look at our graph. I think I have one at -3. Yes, I do. And I have one at -1. X equals -3 and x equals -1. So we're going to strip this down to a quadratic, like some of those girls in my neighborhood were dressing. That's terrible. But yeah, I would have been like totally freaking out if I was like their dad and saw that. What? So we've gotten rid of the -3. Now let's get rid of the -1. So that's a -6, so that's a -23. That'll be a 23, so that'll be a 21. This will be a -21 for a 0. So we get to now deal with 6x squared minus 23x plus 21 equaling 0. Now, I will tell you that in all likeliness, the problem that's going to be on your test is going to be something like the preceding one, the previous one. I'm still just kind of wrapping up the test. I'll show it to you in the next class. So, make it a point. So the product is 126. The sum is negative 23. I need two numbers that make that happen. I'm going to have to start putzing with numbers. No, not 136. I said 126. 21 and 6 now. See, no, definitely not 5. Or maybe 4, no. But 14 and 9, you say. And you said right, very good. Negative 14 and negative 9. I'm obsolete. Yeah, I can never be obsolete. When it's 9x plus 21 equal to 0. So you can take a 2x out, giving me, oh wait, that would be 3x minus 7. I could take a 3 out, or negative 3 out, and give me 3x minus 7 here. So 3x minus 7 and 2x minus 3. So let's put this on our number line. So let's see. Obviously the negative 3, we're going to fill that sucker in. That corresponds to x plus 3. Negative 1 corresponds to x plus 1. Let's see, 3x minus 7, that would be 7/3, positive 7/3, positive 3/2. So here's positive 3/2, which is 2x minus 3. And 3x minus 7, that's 7/3. So 4 negatives. So basically, we just keep adding a plus sign to the mix. So 4 negatives is positive, negative, positive, negative, positive. Now, which one did I want? I wanted the negatives. So negative 3, negative 1, union with 3/2 to 7/3. That's all she wrote. So, what we have to do, now one thing we got to keep in mind is, even though this inequality is less than or equal to, you have to keep in mind some values cannot be included in any way, shape, or form. Now, nonetheless, we need to bring everything over to one side first. So that's the first step we take, is to bring everything over to one side. Now, let's call this 6/1. So we'll multiply the top and bottom of this by x minus 5. So you'll have 4x minus 6 times x minus 5 entirely over x minus 5. So we get 4x minus 6x plus 30 over x minus 5, less than or equal to 0. Negative 2x plus 30 over x minus 5, less than or equal to 0. Now, there are actually a few different ideas we can take with this problem here. One thing we can do is, if we factor out the negative 2, this would become x minus 15 over x minus 5, less than or equal to 0. Now, 15 would not be, I would not give you one like this on a test, because 15, I want to keep all of your critical values between negative and positive 10. So for this, I'm sorry, I would not give you this on a test. Now, if we divided out everything, both sides by -2, you would have x minus 15 over x minus 5. But since we divided by negative, we flip the inequality. And we get this. This, in my opinion, is the easiest way to handle a problem like this. So, the critical values are obviously 5 and 15. Now, could we include the 5? No. And basically, you set everything from the numerator equal to 0 and solve. And x can equal 15. Now, the 5 cannot work. So, x minus 15 over x minus 5. So, we'll have this set up. So let's see, the x minus 15 changes at the 15. And the x minus 5 changes at the 5. So for this, we get positive, negative, and then positive. Now, keep in mind, we only wanted positive. So negative infinity to 5. Now, would this 5 get a parenthesis or would it get a bracket? Parenthesis. Union with 15 to infinity. All right, so let's bring everything over to one side. And what we need to do here is we need to get a common denominator here, multiply the top and bottom of this by x plus 1, and the top and bottom of this by x minus 4. So that's what we've got to get here. So we now need to simplify this numerator here. So we get 3x plus 3 minus 2x plus 8 over x plus 1 times x minus 4 greater than or equal to 0. So we'll have x plus 11 over x plus 1, x minus 4, greater than or equal to 0. So what we have to do here is simply, we're going to have 3 critical points when we do this. So where x plus 11 equals 0, that's going to be negative 11. And we can include that because it's from our numerator. However, the other two, which were from negative 1, x plus 1, we cannot include that one, and nor can we include the positive 4. So, we're going to have 4 different intervals to putz with. So let's see, x plus 11, well that's negative here, but positive to the right. And x plus 1, get negatives here and then positives here. And then for x minus 4, negatives to the left and positive to the right. So this would be ultimately positive, ultimately negative, positive, and negative. So the final answer would simply go from -11 to -1, parenthesis, union with 4 to infinity. Now, I've thrown in this problem here that I'll have you start doing. So for this, the numerator, the sum is going to be 7, and your product is -18. So 9 and -2 are our numbers. Take a 3x out here, x plus 3, take a 2 out here, giving me x plus 3. So this will become x plus 3 times 3x minus 2. Now for the denominator, the sum is going to be -17, and the product is -60. So -20 and 3. 4x squared minus 20x plus 3x minus 15 equal to 0. So you take a 4x out, get x minus 5. Like I took a 3 out of here, that's x minus 5. X minus 5 and 4x plus 3. So basically from this, x equal to -3, x equal to 2/3, and if I'm not mistaken, that was from the numerator. Now the denominator, which I'm actually going to do these in red, x will equal 5, 4x will equal -3, x will equal -3/4. So we got to put these in order on our number line. So let's see here, -3, and that will be a filled in one. -3/4, which we will not fill in. And 2/3. I want to do that in blue. And then 5. All right, so the numerator, x plus 3, 3x minus 2, and then the denominator, x minus 5, 4x plus 3. So the x plus 3 changes at -3. 3x minus 2 changes at 2/3. X minus 5 changes at 5. And 4x plus 3 changes at -3/4. So we get positive, negative, positive, negative, and positive. Now, for this, we wanted it to be less than or equal to 0, so we take the negative. -3 to -3/4, union with, bracket 2/3 to 5. That's what we'll get. All right. So what we'll do here, x will equal to -5 plus 3 root 7. Now, word to the wise. I might just give you one of those, but you would have to realize that its conjugate would also have to be a root. So what we can do here, we find the sum, which is -10, and your product, well, -5 plus 3 root 7, and then -5 minus 3 root 7. And that's going to be -38. So basically the equation is x squared plus 10x minus 38. In fact, let me rewrite that. All right, now we need to find the other equation. So, we get x equal to 4/5 and x equal to -5 over 9. Well, we'll multiply both sides by 5 here. 5x will equal 4. Get 5x minus 4. We multiply out by 9 here. 9x will equal -5. 9x plus 5. So 5x minus 4 times 9x plus 5. We want to multiply those together. We get 45x squared minus 36x plus 25x minus 20. 45x squared minus 11x minus 20. Now, we're going to multiply it by x squared plus 10x minus 38. So we're going to get some big numbers in here. X squared, 10x minus 38, 45x squared minus 11x minus 20. So we get 45x to the fourth, 450x to the third, 45 times -38. We get -1710 x squared, -11x to the third, -110 x squared, 418x, -20x squared, -200x, and positive 760. So it's going to be 45x to the fourth plus 439x to the third, 20 minus 1840x squared plus 218x plus 760. At no time on one of these would I require a part B of it. All right, so for this one, the sum is going to be 13 And the product is going to be negative 140. So we're looking at 20 and negative 7. Now, since this is our numerator, we're going to actually be able to include the values on this. X minus 7 equaling 0. X will equal negative 5. X will equal 7/4. All right, so for the red one, we would get x minus 5 and x plus 1 equal to 0. X minus 5 equals 0. X will equal 5. X plus 1 equals 0. X will equal negative 1. So let's put those on a number line. All right, this seems to have taken on a mind of its own. All right, so let's see. The first one will be negative 5, and that will be included. Let's see, negative 1, however, will not be included because it comes from the denominator. 7/4 will be included, and 5 will not. So basically, yeah, this will start out positive, then negative, positive, negative, and then positive. And we want the negative. Negative 5 to negative 1, union with 7/4 to 5. All right, so for this one, starting off with, x to the 4th plus 5x to the 3rd, and so on, one thing we have to do is basically solve the related equation and get the zeros. X to the 4th plus 5x to the 3rd minus 15 x to the 2nd minus 33x plus 18 equaling 0. So when we do that, we want to find, two zeros and pull them off one at a time. So I see that negative 2 is one of my zeros, and so is positive 3. So what we have to do here is, we'll put a negative 2 in. We'll have 1, 5, negative 15, negative 33, and then 18. Negative 2 times 1 is negative 2. That will be a 3. Negative 2 times 3 is negative 6. That's a negative 21. That's going to be a 42. for 9, and then negative 18 for 0. Now we can do the same thing and put in a 3. So we'll have 1 here. 3 times 1 is 3. For a 6, 6 times 3 is 18. That'll be a negative 3. That'll be a negative 9 for a 0. So we then get x squared plus 6x minus 3 equaling 0. And we need to solve that and figure out what the rational zeros, what those other zeros are going to be. Now, that is going to need to be put into radical form. Move this thing. All right, there we go. So let's move that 3 over. X squared plus 6x will equal 3. Half of 6 is 3. X squared is 9. So we'll have x plus 3 quantity squared equaling 12. Now, the square root of 12 is square root of 4 times the square root of 3, or 2 root 3. So x plus 3 is going to be plus or minus 2 root 3. X will equal negative 3 plus or minus 2 root 3. Now, our next order of business is to plot these zeros in order, and that way we can come up with our sign diagram. Now, we're going to have 5 different intervals. So let's see. Well, this first one, that's negative 3 minus 2 root 3. Now, negative 3 minus 2 root 3, it would just be common sense that it would be less than negative 3 plus 2 root 3. But negative 3 minus 2 root 3 is going to be our first root right here. And the circles are going to get filled in because it is included. So let's see. I think negative 2 is our next one. And we can call this A for shorthand. And then the next one, negative 3 plus 2 root 3. And we can call this B for short. And then the last one will just be 3. So you can put the factors in order. X plus 2, x minus b, x minus 3. So basically, yeah, all negatives on the end, all positives on the other end. And we get 1 positive and then 3 negatives, and 2 positives, 2 negatives, 3 positives and a negative. Ultimately, positive, negative, positive, negative, and positive. Now, do we want it to be greater than or less than 0? Greater than. So we would take the positive, negative infinity to negative 3 minus 2 root 3, and that would get a bracket, union with negative 2 to negative 3 plus 2 root 3, bracket, union with 3 to infinity. So that's what you're going to get. All right, so what was one of the zeros that you could get? All right, let's put in a 5. So 2, 3, negative 50, and negative 75. So 5 times 2, that's a 10. That's going to be a 13. That'll be a 65 for a 15, and then a positive 75 for a 0. So we have 2x squared plus 13x plus 15 equaling 0. So the sum is 13, and your product is 30. Oh, 10 and 3. So we have 2x squared plus 10x plus 3x plus 15 equaling 0. So we can take a 2x out of these, giving us x plus 5, and take a 3 out of these, giving us x plus 5. So 2x plus 3 times x plus 5 equaling 0. Well, that means x is negative 3 halves, and x is negative 5. So we've got our zeros. So what we'll do to respond to that is put it on a number line. So let's see here, negative 5. Negative 5 is the first one, and then negative 3 halves, and then positive 5. Now, I leave those open because it's less than. Wait, yeah, less than, so it's not included. If we put the factors, x plus 5, 2x plus 3, and x minus 5. Now, keep in mind, each of these corresponds to a specific factor. Negative 3 halves, then the 5. So yeah, everything's negative here. The first one is positive, the others are negative. So 3 negatives gives you a negative. This is positive, negative, and positive. So that's the other constant with these. Basically, the signs will not alternate. I mean, they will alternate, I'm sorry. The only time the signs wouldn't alternate is if you had a repeated factor. Now, I'm not giving you one like that on a test, so you don't have to worry. So I wanted the negative. So negative infinity to negative 5 union with negative 3 halves to positive 5. That's it. So, in other words, you have 3x over x plus 3 minus 2 greater than or equal to 0. Now, if we call this 2 over 1, minus 2 over 1, we have to multiply this numerator and denominator by x plus 3. Now, we've got to have a common denominator. That's a non-negotiable here. So then we have 3x minus 2 times the quantity x plus 3 all over x plus 3, greater than or equal to 0. So you have 3x minus 2x minus 6 over x plus 3. And I'll just kind of move this up here. We'll have x minus 6 over x plus 3 greater than or equal to 0. So the big question is, what do we do with these? So we have to set both the numerator and the denominator equal to 0. Now, x minus 6 can equal 0. X will equal 6. That's going to give us a critical point. Now, another critical point will come from x plus 3 equaling 0, or where x is equal to negative 3. Now, what happens here is the inequality the inequality is going to be greater than or equal to 0, but you have to keep in mind, negative 3, we cannot include that. However, the 6, we can, because it comes from the numerator. So we have 3 different intervals with what we need to check here. Now keep in mind, this was x minus 6 over x plus 3. So the x minus 6 corresponds to a 6 here. So basically, our numerator to the right of 6 is positive, but to the left is negative. Now, for the x plus 3, which changes over at negative 3, to the left, that's negative, but to the right, we're positive. Now, negative over a negative, that's a positive. Negative over a positive is negative. Positive over positive is simply positive. So, since it was greater than or equal to 0, we want to include the positive one. So negative infinity to negative 3. Now, will this negative 3 get a parenthesis or a bracket? That will be a parenthesis. Union with 6 to infinity. Now, infinities always get parentheses. What about that 6? That 6 is going to get a bracket. And that's it.
So you only include the ones that were on the numerator?
Yes. Unless that were just greater than, then everything would be getting parentheses. All right, so what we'll do here, 5 over x plus 2 minus 3 over x minus 4. We're going to obviously subtract that, and it'll be less than or equal to 0. Now, we've got to get a common denominator here, so we'll multiply the top and bottom of this by your x minus 4. And for the other one, top and bottom by x plus 2. So then, what's going to happen is you have 5 times x minus 4 minus 3 times x plus 2 over x plus 2, x minus 4. So 5x minus 20 minus 3x minus 6 over all of this. So since we actually have 2 values that make the denominator 0, we're actually going to have 2 intervals that would end in a parenthesis. So for this, we will get 2x minus 26 over x plus 2, x minus 4, less than or equal to 0. So I can factor a 2 out of this. It really makes no difference. But the fact is, it's going to give me x equal to 13. So what we're going to have out of this is we're going to have 3 critical values. So the first one will be negative 2. and that one's not included. The next one would be 4. That one's not included because they both come from the denominator. However, the final one is going to be 13, and we will include that one. So, we have 2 times x minus 13 over x plus 2, x minus 4. So, let's see, the x minus 13 changes here. So basically, that's our numerator. So to the right, it's positive, but to the left, they're negative. The x plus 2 changes at negative 2. So to the left, you're negative, but to the right, you're positive. And then the last one, x minus 4, that changes there. You've got negatives and then positives. So negative, basically 3 negatives gives us a negative. This will be a positive, negative, and positive. Now, since it was less than or equal to 0, I want the negative interval. So negative infinity to negative 2, parenthesis, union with 4 to 13. However, the 13 is going to get a bracket. All right, very good. Very good, folks. All right, so if we go ahead and factor this here denominator, the sum is going to be 7, and the product, negative 30. So you're going to get 10 and negative 3. 2x squared plus 10x minus 3x minus 15 equaling 0. We can take a 2x out of these. That'll give us x plus 5. Take a 3 out of these. That'll give us x plus 5 there. So then x plus 5 gets multiplied by 2x minus 3. So when we set each of these equal to 0, you get x plus 5 equal to 0, x equaling negative 5. And then 2x minus 3 will equal 0, and 2x equals 3. X is going to equal 3/2. Now again, with rational inequalities in any rational function, you will not get any, you shouldn't get any like radical stuff in those. Just very nice, easy to factor problems. Now, if we do the numerator, which was this, 3x squared minus 2x minus 21, the sum was negative 2, and the product was negative 63. So you get negative 9 and positive 7. So 3x squared minus 9x plus 7x minus 21 equaling 0. So we take a 3x out, getting us x minus 3. We take a 7 out, that'll give us x minus 3 equal to 0. So you get 3x plus 7 times x minus 3 equaling 0. So 3x plus 7 equaling 0, x will equal negative 7/3. And then x minus 3 equaling 0, x will equal 3. So there we have our critical values. So now we put them on a number line. Oops. So the first one was -5. Now we cannot include that. Now that corresponded obviously to x plus 5. Now the next one would be x equal to -7/3. We would be able to include that one because it comes from the numerator, and that was 3x plus 7. And then the next one would be, oh, wait. Yeah, oh, that would be -7/3, yes. Then the next one would be 3/2. And we cannot include that one, so that's 2x minus 3. And then the final one, 3, for x minus 3. And we can include that one. So yeah, all this sign diagram stuff, yeah, this is what we're getting. So the 3x plus 7, that first one changes at -7/3. So negatives here, positives elsewhere. And x minus 3, you get negatives to the left and a positive to the right. X plus 5, well, that's negative there, positive elsewhere. And then 2x minus 3, negative to the left, positive to the right. So we get positive, negative, positive, negative, positive. And we wanted it to be greater than or equal to 0, so we include only the positive ends. So we go from -infinity to -5. Now, at -5, will it get a parenthesis or a bracket? It's going to be a parenthesis. Good. Union with -7/3 to 3/2. The -7/3, what's that get? How about 3/2? Then union with 3 to infinity. Well, infinities always get parentheses, but what about that 3? That's a bracket. All right. Almost home here. All right, so for this one, starting off with, x to the 4th plus 5x to the 3rd, and so on. One thing we have to do is basically solve the related equation and get the zeros. X to the 4th plus 5x to the 3rd minus 15 x to the 2nd minus 33x plus 18 equaling 0. So when we do that, we want to find 2 zeros and pull them off one at a time. So I see that -2 is one of my zeros, and so is +3. So what we have to do here is, we'll put a -2 in. We'll have 1, 5, -15, -33, and then 18. -2 times 1 is -2. That will be a 3. -2 times 3 is -6. that's a negative 21. That's going to be a 42 for a 9, and then negative 18 for 0. Now we can do the same thing and put in a 3. So we'll have 1 here. 3 times 1 is 3. For a 6, 6 times 3 is 18. That'll be a negative 3. That'll be a negative 9 for a 0. So we then get x squared plus 6x minus 3 equaling 0. And we need to solve that and figure out what the rational zeros, what those other zeros are going to be. Now, that is going to need to be put into radical form. Move this thing. All right, there we go. So let's move that 3 over. X squared plus 6x will equal 3. Half of 6 is 3. X squared is 9. So we'll have x plus 3 quantity squared equaling 12. Now, the square root of 12 is square root of 4 times the square root of 3, or 2 root 3. So x plus 3 is going to be plus or minus 2 root 3. X will equal negative 3 plus or minus 2 root 3. Now, our next order of business is to plot these zeros in order, and that way we can come up with our sign diagram. Now, we're going to have 5 different intervals. So let's see. Well, this first one, that's negative 3 minus 2 root 3. Now, negative 3 minus 2 root 3, it would just be common sense that it would be less than negative 3 plus 2 root 3. But negative 3 minus 2 root 3 is going to be our first root right here. And the circles are going to get filled in because it is included. So let's see. I think negative 2 is our next one. And we can call this A for shorthand. And then the next one, negative 3 plus 2 root 3. And we can call this B for short. And then the last one will just be 3. So you can put the factors in order. X plus 2, x minus b, x minus 3. So basically, yeah, all negatives on the end, all positives on the other end. And we get 1 positive, then 3 negatives, and 2 positives, 2 negatives, 3 positives, and a negative. Ultimately, positive, negative, positive, negative, and positive. Now, do we want it to be greater than or less than 0? Greater than. So we would take the positive, negative infinity to negative 3 minus 2 root 3, and that would get a bracket, union with negative 2 to negative 3 plus 2 root 3, bracket, union with 3 to infinity. So that's what you're going to get. All right, so what was one of the zeros that you could get? All right, let's put in a 5. So 2, 3, negative 50, and negative 75. So 5 times 2, that's a 10. That's going to be a 13. That'll be a 65 for a 15, and then a positive 75 for a 0. So we have 2x squared plus 13x plus 15 equaling 0. So the sum is 13, and your product is 30. Oh, 10 and 3. So, 2x squared plus 10x plus 3x plus 15 equaling 0. So we can take a 2x out of these, giving us x plus 5. Then take a 3 out of these, giving us x plus 5. So 2x plus 3 times x plus 5 equaling 0. Well, that means x is negative 3 halves, and x is negative 5. So we've got our zeros. So what we'll do to respond to that is put it on a number line. So let's see here, negative 5. Negative 5 is the first one. And then negative 3 halves. And then positive 5. Now, I leave those open because it's less than. Wait, yeah, less than, so it's not included. If we put the factors, x plus 5, 2x plus 3, and x minus 5. Now keep in mind, each of these corresponds to a specific factor. Negative 3 halves, then the 5. So yeah, everything's negative here. The first one is positive, the others are negative. So 3 negatives gives you a negative. This is positive, negative, and positive. So that's the other constant with these. Basically, the signs will not alternate. I mean, they will alternate, I'm sorry. The only time the signs wouldn't alternate is if you had a repeated factor. Now, I'm not giving you one like that on a test, so you don't have to worry. So I wanted the negative. So negative infinity to negative 5 union with negative 3 halves to positive 5. That's it. So, in other words, you have 3x over x plus 3 minus 2 greater than or equal to 0. Now, if we call this 2 over 1, minus 2 over 1, we have to multiply this numerator and denominator by x plus 3. Now, we've got to have a common denominator. That's a non-negotiable here. So then we have 3x minus 2 times the quantity x plus 3 all over x plus 3 greater than or equal to 0. So you have 3x minus 2x minus 6 over x plus 3. And I'll just kind of move this up here. We'll have x minus 6 over x plus 3 greater than or equal to 0. So the big question is, what do we do with these? So we have to set both the numerator and the denominator equal to 0. Now, x minus 6 can equal 0, x will equal 6. That's going to give us a critical point. Now, another critical point will come from x plus 3 equaling 0, or where x is equal to -3. Now, what happens here is the inequality was, the inequality is going to be greater than or equal to 0, but we have to keep in mind, -3, we cannot include that. However, the 6, we can, because it comes from the numerator. So we have 3 different intervals with what we need to check here. Now keep in mind, this was x minus 6 over x plus 3. So the x minus 6 corresponds to a 6 here. So basically our numerator to the right of 6 is positive, but to the left is negative. Now for the x plus 3, which changes over at -3, to the left, that's negative, but to the right, we're positive. Now, negative over a negative, that's a positive. Negative over a positive is negative. Positive over positive is simply positive. So, since it was greater than or equal to 0, we want to include the positive one. So -infinity to -3. Now, will this -3 get a parenthesis or a bracket? That will be a parenthesis. Union with 6 to infinity. Now, infinities always get parentheses. What about that 6? That 6 is going to get a bracket. And that's it.
So you only include the ones that were on the numerator?
Yes. Unless that were just greater than, then everything would be getting parentheses. All right, so what we'll do here, 5 over x plus 2 minus 3 over x minus 4. We're going to obviously subtract that, and it'll be less than or equal to 0. Now, we've got to get a common denominator here, so we'll multiply the top and bottom of this by your x minus 4. And for the other one, top and bottom by x plus 2. So then what's going to happen is you have 5 times x minus 4 minus 3 times x plus 2 over x plus 2, x minus 4. So 5x minus 20 minus 3x minus 6 over all of this. So since we actually have 2 values that make the denominator 0, we're actually going to have 2 intervals that would end in a parenthesis. So for this, we will get 2x minus 26 over x plus 2, x minus 4, less than or equal to 0. So I can factor a 2 out of this. It really makes no difference. But the fact is, it's going to give me x equal to 13. So what we're going to have out of this is we're going to have 3 critical values. So the first one will be -2. And that one's not included. The next one would be 4. That one's not included because they both come from the denominator. However, the final one is going to be 13. And we will include that one. So, we have 2 times x minus 13 over x plus 2, x minus 4. So, let's see, the x minus 13 changes here. So basically, that's our numerator. So to the right, it's positive, but to the left, they're negative. The x plus 2 changes at -2. So to the left, you're negative, but to the right, you're positive. And then the last one, x minus 4, that changes there. You've got negatives and then positives. So negative, basically 3 negatives gives us a negative. This will be a positive, negative, and positive. Now, since it was less than or equal to 0, I want the negative interval. So negative infinity to -2, parenthesis, union with 4 to 13. However, the 13 is going to get a bracket. All right, very good. Very good, folks. All right, so if we go ahead and factor this here denominator, the sum is going to be 7 and the product -30. So you're going to get 10 and -3. 2x squared plus 10x minus 3x minus 15 equaling 0. We can take a 2x out of these. That'll give us x plus 5. Take a 3 out of these. That'll give us x plus 5 there. So then x plus 5 gets multiplied by 2x minus 3. So when we set each of these equal to 0, you get x plus 5 equal to 0, x equaling -5. And then 2x minus 3 will equal 0. And 2x equals 3. X is going to equal 3/2. Now again, with rational inequalities in any rational function, you will not get any, you shouldn't get any like radical stuff in those. Just very nice, easy to factor problems. Now, if we do the numerator, which was this, 3x squared minus 2x minus 21, the sum was -2, and the product was -63. So you get -9 and +7. So 3x squared minus 9x plus 7x minus 21 equaling 0. So we take a 3x out, getting us x minus 3. We take a 7 out, that'll give us x minus 3 equal to 0. So you get 3x plus 7 times x minus 3 equaling 0. So 3x plus 7 equaling 0, x will equal -7/3. And then x minus 3 equaling 0, x will equal 3. So there we have our critical values. So now we put them on a number line. Oops. So the first one was -5. Now we cannot include that. Now that corresponded obviously to x plus 5. Now the next one would be x equal to -7/3. We would be able to include that one because it comes from the numerator, and that was 3x plus 7. And then the next one would be, oh, wait. Yeah, oh, that would be -7/3, yes. Then the next one would be 3/2. And we cannot include that one, so that's 2x minus 3. And then the final one, 3, for x minus 3. And we can include that one. So yeah, all this sign diagram stuff, yeah, this is what we're getting. So the 3x plus 7, that first one changes at -7/3. So negatives here, positives elsewhere. And x minus 3, you get negatives to the left and a positive to the right. X plus 5, well, that's negative there, positive elsewhere. And then 2x minus 3, negative to the left, positive to the right. So we get positive, negative, positive, negative, positive. And we wanted it to be greater than or equal to 0, so we include only the positive ends. So we go from -infinity to -5. Now, at -5, will it get a parenthesis or a bracket? It's going to be a parenthesis. Good. Union with -7/3 to 3/2. The -7/3, what's that get? How about 3/2? Then union with 3 to infinity. Well, infinities always get parentheses, but what about that 3? That's a bracket. All right. Almost home here. So, what else has to be a root? That's correct. X equal to -5 plus 7√2 must also be a root. So, now that we have our roots, what we can do is we can do this either the long method where we convert each of these to factors, or we can take the product and the sum of the roots. Either way, we're going to get the same thing. So if we did -5 minus 7√2 plus -5 plus 7√2, when you add those up, what do you get? Slight hint, anything with the radical is gone. So basically, all you're left with is -10 for this sum. So basically, we have, it's always going to be an x squared, and it will be plus 10x. Now remember, if you did the sum, the leading or the middle term is the additive inverse. So if the sum were positive 10, then this would have been negative 10x. Now let's find the product. So when we go to find the product of this sucker, let's see what we get. We get -73. So guess what? That's it. Plain and simple here, boys and girls. You know, when I first, when I actually started teaching this, this was the method that I knew and embraced. That second method, I like to thank Janet Dale, my old department chair from Comparing the Floor. She actually showed me some other ways of doing problems. So it was pretty cool how that worked. Now, if we want to verify this, we can pull this up on the calculator. Now, the thing is, it's not going to, the calculator, when we graph this, it's not going to give us a answer in simplest radical form. Why? Because, well, it just doesn't do that. But if we graph x squared plus 10x minus 73, when we go to do that, now this is a case where, yeah, I might actually zoom out. Now, the two roots were -5 minus 7 root 2. -5 minus 7 root 2. Oh, not 7 squared, that would give me something I didn't expect. And that is basically 0 thanks to scientific notation. And -5 plus 7 root 2. And we get 0 there. All right. Look at a case where we have I'm giving you an imaginary root or a complex root now. So if 5 minus 7i is one of our roots, how would we even get started on something like this? Well, we need to figure out the other one. What would the other root be? X equals 5 plus 7i. Now, I will give you a little spoiler alert that the sum and product rule works exactly the same way. However, I am going to do this using both methods, with the factoring and the sum and product rule, just to kind of prove a point. So for this, we get x minus 5 plus 7i, x minus 5 minus 7i. X minus 5 plus 7i, x minus 5 minus 7i. So x times x is x squared. And that's what this would always start off with anyway. X squared, x times negative 5x. We get 7ix or 7xi. It doesn't really matter what happens anyway because it's going to be offset in a minute. We get negative 5x, positive 25, negative 35i, negative 7ix, positive 35i, and negative 49i squared. Well, remember, what is I squared? I squared is negative 1. So basically, at negative 49 times negative 1, which is just positive 49. Now, all that can just kind of go by the wayside. And what we're going to get here is x squared minus 10x. 25 plus 49, 74. Boom. That's it. Plain and simple. Now, if I did the sum of the roots, 5 minus 7i plus 5 plus 7i, that's going to be positive 10. Opposite of that is negative 10. Pure and simple. And for the product, 5 minus 7i, 5 plus 7i, well, it's just 25 minus 49i squared equaling 74. Boom, right there. Plain and simple here. All right, what's the other root going to have to be? Negative 7 minus 8i. So using the standard original method, you have x equal to negative 7 plus 8i, and x equal to negative 7 minus 8i. If we convert the both of these to factors and multiply them out in the grid, but then we'll do the sum and product, we'll get the same thing. But I'm just merely trying to prove to you that you can do it even with imaginary numbers. So you have x plus 7 minus 8i, x plus 7 plus 8i. And just like before, any imaginary parts that you had will end up getting offset in here. So for instance, we know x times x is x squared. We got 7x here, negative 8ix or negative 8xi. It doesn't matter because it's about to offset with something else. You get 7x, 49, negative 56i. You get positive 8ix. Get positive 56i, and then negative 64i squared. Now, keep in mind, I squared equals what? I squared is negative 1. So for this, that's negative 64 times negative 1 for 64. We combine all like terms and get x squared. Well, first off, all this gets canceled out. Plus 14x, 49 and 64 adds, I believe, to 113. Now, So we can also do the shortcut. You know, if we do the sum, -7 plus 8i plus -7 minus 8i, well, the 8i's are offset with each other, and we get -14. Well, the inverse, or, you know, opposite is okay to say, but if you actually said that to a purely mathematician, somebody who's a pure mathematician, the technical term is additive inverse. And if we do the product, -7 minus 8i, -7 plus 8i. The product of that is going to be 113. So that's simply how it all works. All right. All righty then. So if we have the one root as -5 minus 3i root 2, -5 plus 3i root 2 is our other root. So the sum of these two, well, that's going to be very easy. -5 minus 3i root 2 plus -5 plus 3i root 2. When you add them up, we get -10. Now, when we take the product, -5 minus 3i root 2, -5 plus 3i root 2, and I'm just going to use my calculator. -5 minus 3i root 2. What are you all talking about? Oh, Siri. 43. So the equation is x squared plus 10x plus 43. Now keep in mind the opposite of that. Opposite of the sum. So basically, I'm now going to give you, -4, -57. So -57 will equal, let's call the constant r times -4 squared plus 10 times -4 plus 43. So, yeah, -4 squared plus 10 times -4 plus 43. We get 19, or 19r. So r is -3. So basically, we multiply the whole enchilada by -3. So the final answer is going to be -3x squared minus 30x minus 129. So that's what it's going to be. Now, I will tell you, all right, so for this next example, well, we're now going to do some applications of this where we're going to be using quadratic equations. So we're going to shoot an object into the air from 500 feet high at a given rate upward of 40 feet per second. Now, this is the equation that results from this. I'm going to give you the equation. But I'm kind of a physics dork. when it comes to this stuff. So f of t is negative 32t squared plus 40t plus 500. So we're shooting it from someplace 500 feet high. And basically what will happen is it's going to reach a maximum height, and then it's eventually going to hit the ground again. Now, how many of you have taken a physics class? All right, well, basically this represents the acceleration due to gravity, and that's in feet per second. It's really more like 32 point something small, but if we were doing this with the metric system, it would be in meters per second squared. Like, basically, if you drop an object, gravity causes it to accelerate. The velocity of an object falling theoretically should be gaining speed. Now, in reality, you're not, because you typically reach what's called terminal velocity, based on air resistance. So, like if you were skydiving from a plane, you probably wouldn't be, you could actually use an equation like this theoretically to see how long it would take you to hit the ground again. Well, the thing is, it wouldn't be completely accurate, and the reason is because of air resistance. But think of it in a vacuum where like all the air is sucked out. Like that's it in a vacuum. If you drop a feather and a bowling ball, they would both land at the same time. No air resistance. Okay, that makes me want to show you something. Basically, what happens here, and I can show you the graph of this. Now, the path of the quadratic equation is kind of like this, except we're actually starting from 500 feet high. So what we need to do is, f of t equals this, where t is the time in seconds. F of t represents the height at time t. So we need to determine where the time where the object reaches its maximum height, and at the time the object hits the ground again. Now we're also going to determine the maximum height itself. Now, here's the thing. If we did negative b over 2a, that is going to give us the maximized height time. Remember, negative b over 2a. That's real easy to remember because it's part of your quadratic formula. So you have negative 40 over 2 times negative 32. And so basically, it's 40/64. And it's going to be 0.625 seconds. That's pretty quick. Now, that is, in fact, the time where the maximum height occurs. Now, for the max height itself, all you have to do is replace the t with 0.625. So what we would do here, negative 32 times 0.625 quantity squared plus 40 times 0.625 plus 500. Now, it's 512.5 feet. Not very much, is it? Basically, yeah, when you shoot something upward, thanks to gravity, and plus we only shot it at 40 feet per second. If we had shot it at a higher velocity, it might be in the air longer. Now, so we're now going to determine when the object hits the ground again. So basically, for it to hit the ground again, we would be setting f of t equal to 0 for the ground. In other words, negative 32t squared plus 40t plus 500 is going to equal 0. Now, I will tell you this. Don't try to factor this. Use quadratic formula. And don't worry about radicals or anything like that. Because, yeah, just don't, please. So, if I go through this, first we need to figure out b squared minus 4ac. So that is 40 squared minus 4 times negative 32 times 500. That's 4 times negative 32 and 500. And we get 65,600. And the square root of that, the square root of 65,600 is 256.12. So basically, continuing on with the quadratic formula, you would have negative 40 plus or minus 256.12 over negative 64. Now, you are going to get one negative answer and one positive answer. Now, for the negative answer, just throw that out. Basically, here's what would happen. The negative answer would be here. Now, the positive answer is what we're looking for. So, if we do, negative 40 plus 256.12 and divided by negative 64, we get negative 3.38. So we'll just throw that out. Negative 40 minus 256.12, and then divide that by negative 64. We get 4.63 seconds. So that's how it works. Now, let's graph that equation. Obviously, we can't do t, we'll do x. Plus 40x plus 500. Now, if we have to putz with our window values a bit, I'm going to let the x min be negative 5. I'm going to let the x max be 6. Now, the maximum height was 512. Let's call it 550 here. But basically, this is where the object is shot off. So it is going to reach a maximum height. In fact, let's go to the window value. Let's make that x min 0. And yeah, you can see right there, there's your max. So And if you actually, you could actually do this, 0.625, and found it this way as well. So, pretty cool. All right. I'm going to want you to try the next. So basically, let's see when the object reaches its maximum height. So we have negative b over 2a. So negative 120 over 2 times negative 32. Basically 120 divided by 64. Oh, should have been times that. Divided. So 1.875 seconds. So yeah, this object is going to stay in the air quite a bit longer. And so the time it takes to hit the ground is probably going to be significantly higher. But let's figure out the max height. So the max height would be negative 32 times 1.875 squared plus 120 times 1.875 plus 1,500 . And so we get 1,612.5 feet. So the last object only climbed a very small amount of feet. This object actually climbs over 100 feet before it starts going down. Now keep in mind how long the object climbs has no, the height from where it's shot from does not have an impact on that. It is basically how fast we shoot it off. Now it's possible we could shoot it just downward, but that's more like directly aiming at something. So let's now figure out how long it takes for this sucker to hit the ground. So, in fact, I'm going to do the square root of the discriminant right off the bat. And we get 454.31. So basically, negative 120 plus or minus 454.31 over negative 64. So minus 454.31 divided by negative 64, we get 8.97 seconds. So 9 seconds from time it's and the other one would be negative. I wouldn't require it, but I'm just going to put it up there just to show it to you. Yeah, negative 5.22 seconds. So that's how it works. Projectile motion at its finest. Yeah, the whole world of physics. Yeah, physics is really amazing. All right, so we're going to go ahead and hit on this next one. So we have negative 32t squared plus 50t plus 800. So if we do negative b over 2a, we get negative 50 over 2 times negative 32, which is basically 50 over 64. And as a decimal, we can round that to 2 places. Basically, it would be 0.78 seconds. So f of 0.78. Now, if you went more than 2 decimal places, that would be fine. But if we did 0.78, it would be 819.53 feet. So yeah, after 0.78 seconds, our object reaches its max height of 819.53 feet. Now, we need to figure out when that object is going to hit the ground again. So we would do negative 32t squared plus 50t plus 800 equal to 0. So let's see, 50 squared, heck, since we're not simplifying a radical, let's just do the square root right now. Negative 32 and 800, we'll round that to 2 decimal places. 50 squared minus 4 times negative 32 and 800, and we get 323.88. So basically, we have negative 50 plus or minus 323.88 over negative 64. So only one of these is going to work. Basically, if I do negative 50 minus 323.88 and divide it by negative 64, I get 5.84 seconds. All right, so that's how we do a projectile motion problem. So, next, to enclose a rectangular region just such as this. So, we need to figure out the dimensions that maximize the area of the fence. So we can call these L's, we can call these W's. It really doesn't make a difference. Now, area is length times width. Now, we can't really do anything because our length and width are 2 separate variables for the time being. However, we know that 2W plus 2L is going to equal 300. Now, that equation comes straight from the fact that the perimeter is 300. So what you are going to do here is you would solve this for L or for W. Now, since it's 2W plus 2L, you would get exactly the same thing in different spots. I don't know. I think I'm going to solve this for W. So I would get 2W equal to 300 minus 2L. And then I'll divide everything out by 2. So W will equal 150 minus L. Well, the same thing works. L would be 150 minus W. It's really no difference. Now that we have the equation solved for the other variable, area is length times, now our new width is 150 minus L. Basically, all you need to do is substitute. Make your substitution. And it's that. So basically, area is going to be 150L minus L squared, or negative L squared plus 150L. Now, we're not done yet. Now, if you had solved this for L, basically the equation would have been reversed either way. So we need to find the maximized length. And guess what? Negative B over 2A never goes away, does it? So negative B, so that would be negative 150 over 2 times negative 1, so that the L would be 75 yards. Now that our length is 75 yards, we can figure out the width by replacing this L with 75. The width is 75. Now the area, we could actually do, the area is 75 by 75, which happens to be 75 squared, or 5,625 square yards. Now there is another way we could have figured out that area. If we replaced this L with 75, 150 times 75 minus 75 squared, you get the same thing. Now, if the length and width are the same, that means, well, technically it is a rectangle still, but in reality, it is a square. Now, I want you to try this problem where I'm giving you, all right, so for this one, we still have 2 L's and 2 W's. 2L plus 2W is now going to be 500. So what we'll do is we'll solve this for either L or W. This time we're going to solve it for L. 2L will be 500 minus 2W. Dividing everything out by the 2, we get L equal to 250 minus W. So, now keep in mind, area is length times width. Now that I have my equation for length, which is 250 minus W, I have 250 minus W times W for 250W minus W squared, or negative W squared plus 250W. If you had solved this for W, those would be L's, plain and simple. Now, what happens here, we need to maximize or optimize, so negative B over 2A negative 250 over 2 times negative 1, that's going to be 125. So that means length is 125 as well. Now, here's the thing. For a case simple like this, basically, yeah, making this a square is what maximizes this. Now, that's going to change. It's not going to be a simple case, I'm afraid. And it's going to be 15,625 square yards for the area. Now, I'm going to work through the next one. But here's the thing. If I were to call these W's, I would be calling these L's. Now, area is always going to be length times width. That is never going to change. Never. Now, what is the equation that represents the perimeter? Two W plus 4L equals 1,200. Now, here's the thing. As I said, we're going to take this 2 different ways. So I'm going to draw a line down the middle. 2W plus 4L equals 1,200. And we're going to solve for W. So we're going to take that approach and solve this for W first. So 2W will equal 1,200 minus 4L. And then we divide out everything by 2. So W will equal 600 minus what? 2L. So we have our W in terms of the length. So now area is L times W again. So L is L, but W is 600 minus 2L. So for that, we get 600L minus 2L squared, or negative 2L squared plus 600L. Now, we're going to continue with that idea where we're going to max the length. That's negative B over 2A. Well, that would be negative 600 over 2 times negative 2. And this gives us 600 over 4 for 150. Now, our length is 150. Now, to find the W, now remember, the W was 600 minus 2L. So I replace this L with 150. So the W is going to be 300. And now the area, it is L times W, which is 150 by 300. Or 45,000 square yards. Now you could have also done negative 2 times 150 squared plus 600 times 150. You would be getting the same exact thing. Now, that's how to do it if we solve this initial equation for the width. Now, what if we chose to solve that equation for the length? Now, it's not going to be exactly the same thing. 2W plus 4L equaling 1200. We're going to now solve it for L. So that's what we'll do. So 4L will be 1200 minus 2W. And what we're going to do is divide everything by 4. So L will be 300 minus 2/4 W. Or we could say 300 minus what? 1/2 W. So there's our length in terms of the width. Now, keep in mind, area is still and always will be length times the width. There will never be anything different about this. So the L is 300 minus 1/2 W, and the width is the width. So we went from having, just like before, we went from having 2 variables into 1, just like here. Now, a little FYI, you will not have to use both of these. I am trying to show you that it works either way. So we get 300W minus 1/2 W squared, or negative 1/2 W squared plus 300W. Now, we need to maximize the W. So that's negative B over 2A. That never changes. We get negative 300 over 2 times negative 1/2. Well, that's negative 300 over negative 1 for 300. So there is the width that we get. Now, we're going to plug that W into the L equation. Now remember, L was 300 minus 1/2 W. So that's 300 minus 1/2 times 300 for 150. Hey, guess what? We have the exact same thing as before. 300 by 150. Now, am I going to make you do it both these ways? No. Instead, you just have to solve for one of the variables and go that way. I did it for both to prove a point. Give you a moment. So, I am going to solve this for L. So, I'm going to solve this for L. So So 4L will equal 1500 minus 3W. We divide out everything by 4. So we got to do the 1500 divided by 4, which is 375. So L will be 375 minus 3/4 W. Now, if you solve this for W, I believe you would get 500 minus 4/3 L. I'm not going to go through the whole work, but again, if you solve this for W, W would equal 500 minus 4/3 L. So if you got that, you're on the right track. Now, area is length times the width. Well, the length is 375 minus 3/4 W, and the W is W. Negative 3/4 W squared plus 375 W. So let's maximize that width. That's negative B over 2A. That's negative 375 divided by 2 times negative 3/4. So negative 375, 2 times negative 3 over 4. And we get 250 for the width. Now, the corresponding length, 375 minus 3/4, but instead of W, you get 250. And we get 187.5 for the length. Now, if you had solved that for width and done the math, you would have gotten the same thing. That's what I love about these problems. It all works out. So, the area is 250 by 187.5. Now, neither dimension would have a decimal on the test. 46,875 square yards. That's a lot of square yards. Because, yeah, that's a couple of acres. It's a lot of acres, really. You know what green acres are? They're what Kermit the Frog gets when Miss Piggy kicks him in the groin. Green acres. Get it? So for this one, 1,500 yards of fencing, we can call these W's. We have 1, 2, 3, 4, 5, 6 W's and 2 L's. So 6W plus 2L is 1,500. So we now have the choice whether to solve this for W or to solve it for L. What do you think you would want? What would you solve it for? L. You know what? I would too. So 2L will be 1,500 minus 6W. We divide out by the 2. We get L equal to 750 minus 3W. So there's our length. Now, if you did solve this for W, you would get, let me see, 1,500 divided by 6, that's 250. 250 minus 1/3 L. So if you did it that way, that's what you would get. You know, the math all works out. See, this is why I love to teach math, because it all works out. Now, with this in mind, area is simply length times the width. So the length is 750 minus 3W, and the W is W, which gives us negative 3W squared plus 750W. So let's maximize that width. You know, that's negative B over 2A. So that would be negative 750 over 2 times negative 3. Or 750 basically divided by 6, we get 125. So we get 125 for the width. So the length is 750 minus 3 times 125. And we get 375. So if you had done it the opposite way, you would have found the length and then the width. Basically, it's how it works with this. So there's your width, there's your length. Area is 125 by 375. $46,875 square yards. So that's a lot of square yardage. Is the equation that relates that gives you the perimeter. Let's see, we'll have 2W plus 4L equaling 1,600. So we're going to solve this one for W and work at it. And we're going to do the same thing, but solving it for L. Now, also, just remember the fact that area is, in fact, your length times your width. Now, we're going to do this one solving for, in fact, W. So in order to solve this for W, you get 2W equal to 1,600 minus 4L. And then we're going to divide everything out by 2. And for that, we will get W equal to 800 minus 2L. Now, that does not mean, if you had solved this for L, you're not going to get the same thing. But in doing the math correctly, it will all work itself out. Now, since the width is 800 minus 2L, now remember our area is in fact length times width. So our length is just going to be the length, but our width is now 800 minus 2L. So what we're doing here, like we've done in previous examples, is we've gone from having this in terms of 2 variables down to 1. So what we're able to do now, we get 800L minus 2L squared, or negative 2L squared plus 800L. So in this case, we're going to maximize the length, and that's going to be negative 800 over 2 times negative 2, and that's equal to 800 over 4, or 200. So basically, L is going to be 200 yards. Now, since the length is 200 yards, it follows that the width, 800 minus 2L, 800 minus 2 times 200, we get a width of 400 yards. So then, the area, we could actually figure that out 2 different ways. Simply L times W, that's 200 times 400, that is 80,000 square yards. Now that's a lot of acres. That's a few more acres. But if you actually did negative 2 times, negative 2L squared plus 800 times 200, so yeah, 200 times 400, yeah, 80,000. If you did negative 2 times 200 squared plus 800 times 200, well, not 20, but 200, you get the same thing. So that's, if you solved it, that's, solving it for W. Now, when we solve this for L, here's the neat thing. We're going to solve this for L, so we'll have 4L equal to 1600 minus 2W. Now, when we divide out by 4, L is going to be 400 minus 2/4 W. But let's replace that. Let's simplify the 2/4 with a 1/2. So that's what our length is going to be. 400 minus 1/2 W. So, yeah, so whether you solve it for W or L, you are going to get a different equation. But after doing the operations, you will see the dimensions work out exactly the same. So, since the area is length times width, well, the length is 400 minus 1/2 W, and the width is just W. We get negative 1/2 W squared plus 400 W. That's our area in terms of the width. Now, our area in terms of the width. So now we're going to maximize the width. Which is still negative b over 2a. So that's negative 400 over 2 times negative 1/2, which gives us 400. See, we get the, so in this case, what happened was we got the width first. Now, the corresponding length, 400 minus 1/2 times 400 is 200. So, yeah. So, in other words, my friends, it does not matter which way we solve this, whether we solved it for L or for W. Am I going to make you do it both ways? No way. But it goes to show that either way it works. And I'm not going to do this for every problem that we do. But I personally would have preferred to solve this for W because it avoids fractions. But if you solved it for L, I mean, yeah, either way. Let's solve this by factoring. So we need to find two numbers that have a sum of 5 and a product of negative 36. And those numbers are going to be 9 and negative 4. So basically, we get 3x squared plus 9x minus 4x minus 12 equaling 0. Now, we factor by grouping. And the reason I always like to start this off with factoring, do one that's factorable. Some of these other ones won't be factorable like this. But you'll see why I do this. We could take a 3x out, and I get x plus 3. And we can take a negative 4 out, and I get x plus 3 equal to 0. So I get x plus 3, and it's going to be multiplied by 3x minus 4 equal to 0. Now, over here is where I'm actually going to do the solutions to this. So x plus 3 equal to 0. X will equal negative 3. Now, I want you to also keep in mind what, the solution and what the factor was. That's going to help us with sign diagrams. We get 3x minus 4 equal to 0, 3x equaling 4, x will equal 4/3. So there's our two solutions. Now, so yeah, you really should know how to do quadratic equations by this point. You really should. So we're going to, now what I'm going to do here is I'm going to put them on a number line in order. So the first one would be negative 3. And then the other one would be 4/3. Now, so we're going to do this using the traditional method first. Now, we have an interval with 2 points on that interval. Now, how many different intervals do we actually have here? How many different intervals? We have 3. And we're going to call them A, B, and C. Now, you also need to remember, the equation was 3x squared plus 5x minus 12, and that was, in fact, greater than or equal to 0. Now, what we're going to do is we're going to come up with some test points. So, interval, A, B, and C. Then we'll have a test value. So if we, so for interval A, what would be a good test value for x that we could try? Just any value in this interval. Negative 2? Try negatives. Negative 5, okay. How about for B? 0, my favorite. And for C? Something greater than 4/3. 5. So now we're going to do the test point for A. That would be 3 times -5 squared plus 5 times -5 minus 12. Now, what does that equal? Well, we just punch it up on our calculator. We get 38 for that. Now, is it greater than or equal to 0? Yes. So what this means is A is a valid interval. Now we're going to test something from B. Well, we're going to test 0. 3 times 0 squared plus 5 times 0 minus 12. Well, that equals -12. Is that greater than or equal to 0? No. Now let's test something from C. 5. So 3 times 5 squared plus 5 times 5 minus 12. Well, let's see what that is. 88. And that is certainly greater than or equal to 0. So what that means is both A and C are the intervals that this works for. So basically, the final answer would be from -infinity to -3. Now, would the -3 be a bracket or a parenthesis? It would be a bracket. Union with what to what? 4/3 to infinity. Now, this is certainly correct, and I am not going to begrudge you for doing this method. However, I am going to show you the other method. And we'll call this the sign diagram. So, we're going to make another interval or another number line. And we'll have, -3. And I'm drawing that in blue. Now, the factor that corresponds to -3, what was the factor that corresponded to -3? What factor gave us that? Well, just look up here. X plus 3. Now, the other one was 4/3. What was the factor that gave you 4/3? 3x minus 4. Very good. Now, this is going to seem all too simple, and it really is. Now, x plus 3 to the left of -3, such as -5. If x were -5, would x plus 3 be positive or negative? It would be negative. And since it changes at -3, to the right of that, it would be positive. So it's going to be positive on this side, but if it's greater than 4/3, it's still going to be positive. Now, 3x minus 4. At what point does that one change its sign? Four-thirds. So if it were to the left of 4/3, it would be such as 0? No, it would be negative. And to the right, it would be positive. Now, what's negative times negative? Positive. What's negative times positive? What's positive times positive? Now, the original inequality was greater than. And since it was greater than, which ones do you want? So while the first method is very useful, it is a lot more work in the sense that you have to find values. But either way, you do have to find the points, and you have to know, where the factors change. Yeah. So yeah, these sign diagrams can make this much less painful for you. So what we're going to do next time, we're going to continue on with these. I'm going to introduce to you quadratic polynomial, basically quadratic inequalities. So just like equations, we can solve quadratic inequalities. Now, I'm going to show you two different approaches, and you are going to decide which one you like better. Generally, the book would have you finding critical points and then having you use test points to check. I actually learned how to do these with sign diagrams thanks to Miss Dale. Now, basically, we have to solve the related inequality either way, or the related equations. So we're going to do this two different ways, the conventional way and with sign diagrams. So basically, we just have to solve the related equation, 3x squared minus 2x minus 5 equal to 0. So what we're going to be able to do with that is figure out what are the solutions to this. So if we want to do that, we could actually do this with factoring. If the sum is -2 and the product is -15, the two numbers that make this true are -5 and 3. So then we will factor by grouping 3x squared minus 5x plus 3x minus 5 equal to 0. And then we factor by grouping. So I could take an x out of these first two, and I get 3x minus 5. I can only take a 1 out of these next two, so it'll just be a 1 times 3x minus 5 equaling 0. So I'll have 3x minus 5 times x plus 1 equal to 0. And what I would do here is, set each of these bad boys equal to 0 and solve. 3x will equal 5, x will equal 5/3. X will equal -1. Now, the other thing we're going to notice is, the factor and the solution. I want you to kind of keep that in mind as well. So, we have our two solutions. Now, that's a non-negotiable. So, the traditional, so if you read the textbook, we need to do test points. Actually, what I'm going to do here is I'm going to plot these on the number line just like this. Here's -1, which would be included, and here is 5/3 in order. Now, how many different intervals is this going to result in? Now, by the way, the clock on there runs a little bit faster. We have 3 different intervals. -1 and +5/3. And we fill them in because they are included. So we'll have one from interval A, B, and C. So for the interval, and we pick a test value. So for A, what would be a good test value? X would equal what? -2. For B, what would be a good test value? Perfect. And for C, 6, okay. So what we need to do now is we test each of these. So now keep in mind the interval the inequality was 3x² minus 2x minus 5 greater than or equal to 0. So for A, let's see, 3 times -2 squared minus 2 times -2 minus 5, question mark, because we have to do a little bit of math to figure that out. 3 times -2 squared minus 2 times -2 minus 5, we get 11. 11 is greater than or equal to 0. That is true. So, this is true. Now, when we go to test out B, we'd have 3 times 0 squared minus 2 times 0 minus 5 greater than or equal to 0. -5 is not greater than or equal to 0. And then for C, 3 times 6 squared minus 2 times 6 minus 5 greater than or equal to 0. We get 91. So that's true. So basically, it is intervals A and C. So, I know we're not going to get to the other method of this today, obviously, but basically, since it's intervals A and C, we would go from -infinity to -1 bracket, union with 5/3 to infinity. Now, Tuesday we'll learn sign diagrams. I think they'll be easier. All right, that's it. I want to go over this exact same problem, this time with the sign diagram. And it's going to be up to you to decide which one you think you like better. So the first method simply involved finding test values, determining whether they made the inequality true or false. And this is more or less, a perfectly good method to do. However, what I do want to do is I want to show you method 2, the sign diagram. And it's going to be up to you to decide what method you want to use. Now, so regardless of what happened before, you have to put the roots in the right place. So the first root that we found was -1. Now, what was the factor that corresponded to -1? What's the related factor for that? Give you a hint. Look here. We got x equal to -1. So the corresponding factor was simply x plus 1. Now, and the circle will be filled in because the inequality was greater than or equal to 0. So I'm going to put 5/3 here. Now, what was the factor that corresponded to a root of 5/3? 3x plus 5. Very good. Now, this is going to seem easy because in all reality, it is. So x plus 1. Now, we still have 3 intervals that we're working with, by the way. So x plus 1, to the left of -1, would x plus 1 be positive or negative? It would be negative. But to the right of it, x plus 1 will be positive. Now, we have to put a positive for this interval because there was 3 of them. Now, oh, that was 3x minus 5, but it's basically the same exact idea. So 3x minus 5 to the left of 5/3, would it be positive or negative? To the left? It would be negative. For instance, if I tried 0, yeah, that would be negative. So that's negative and that's negative, but to the right, it's positive. So basically, think of it this way, like these are the 2 factors that are multiplied together. These are the corresponding signs in each interval. Now, a negative times negative is what? Positive times negative is? Positive times positive is? Now, the original inequality, did we want it greater than or less than or equal to 0? since it was greater than, we want the positive parts. And that's it. So we get the exact same answer as we did before. Now, aside from finding the roots, wasn't sign diagram went a lot quicker, didn't it?
Mm-hmm.
Yeah. So yeah, that's how you're going to do that. Graphing calculator. So let's see, that would be 3x squared minus 2x minus 5. Now, in order for this to be, we wanted it to be positive. So what we had to do here, what we have to consider are the parts. In order for it to be positive, we had to consider what was above the y-axis. And as you can see, there's two separate intervals. And since there's two separate intervals here, it makes sense that it's the same way here. So now you can see it both ways. Of course. All right, so the nice thing about this is we can easily factor this into x plus 7 times x minus 2 equal to 0. And because the two numbers had to have a sum of 5 and a product of negative 14. So then it'll just simply follow that you set each of these equal to 0. So x will equal negative 7 and x will equal positive 2. Now, what we're going to do then is we're going to put them on a number line. Now, let's see here. This is less than or equal to, so the dots are going to be filled in. So this first one will be negative 7. And obviously, that corresponds to x plus 7. Now, the other one corresponds to a value of x equal to 2, and the factor is, in fact, x minus 2. So, if we look at the first root of negative 7, anything to the left of this is going to be negative, and anything to the right of it is positive. Now we look at the x minus 2. So for that, and that corresponds to where x is positive 2. So as always with sign diagrams, anywhere to the left, it's negative, and to the right of that is positive. So that's the thing with these sign diagrams. The main idea is never going to change. Basically, the sequencing of these sign diagrams is you're going to have nothing but negatives on one end and then nothing but positives on the other. So, negative times negative is, then positive times negative is, and then positive times positive is positive. Now, if we look, we wanted this less than or equal to, so which do we want? We wanted the negatives. So basically, what happens here is that this is just one single interval from -7 to +2. Now, I'm going to go a little bit deep. I'm not going to go deeper in the problem, but what I want to do is, when you graph the we're going to graph the equation on the calculator. Now, when I do that, now just to, drive the point home that, I want to make sure I can see the whole thing. So we're going to change that Lyman to, I don't know, -30. There we go. Could have made it something else, but here's the thing. So when I go to do this, now remember, we wanted the inequality to be less than 0. And in order for this to, in fact, be less than 0, is it above or below the x-axis? Remember, we're looking for where this is less than or equal to 0, so it's everywhere below. And if you notice, it's just a range of values, one range. So just another nifty way to see how it all comes together. All right. So we actually don't have to go through a hugely difficult process to factor this. We just need two numbers that have a sum of 6 and a product of -27. Oh, just 9 and -3. So basically, we get x plus 9 times x minus 3 equal to 0. So x plus 9 will equal 0. X will equal -9. X minus 3 will equal 0. X will then equal 3. So then, what we're going to do, we're going to make our sign diagram. So the two roots are, in fact, -9. Now, what was the factor that corresponded to -9? X plus 9. Very good. And the other root was +3, which that will correspond to x minus 3. So the same rules apply for sign diagramming. So x plus 9 changes at -9. To the left, it's negative, but to the right, it's positive. And x minus 3 changes at 3. To the right, we're positive, but to the left, we're negative. So negative times negative is positive. Positive times negative is, and then positive and positive. Now, we wanted this to be positive, so as an interval, we would go from -infinity to what? -9, bracket it, union that with 3 to infinity. Now, if you want, you could pick values from each and test them in the original inequality. you'll get the same exact solution. Now, it's perfectly legitimate. You could do that. You know, it does take more time, in my opinion. So what you could do is we could factor a -1 out right now, and that would give us x squared plus 2x minus 15 greater than or equal to 0. Now, we could deal with the x squared minus 2x, plus 2x minus 15. But we could also, in fact, I am going to show you this 2 different ways. You know, method 1 will involve proceeding with this. But method 2, let's say I could just divide out by -1 on both sides. But when I do that, what happens to the inequality? We have to flip the sign. And it's the same exact inequality. I mean, it's the same exact thing. We could have added x squared 2x and subtracted 15 from both sides and gotten it that way. So factoring this sucker, what's this going to factor into? X plus 5 and x minus 3. So then, you know, we get x plus 5 equal to 0, x minus 3 equaling 0. So basically, x will equal -5, or x will equal +3. Now we can make our little sign diagram based on that, based on this, where, you know, -5 is our first one, and that obviously corresponded to x plus 5. Our other one was 3. And that's going to correspond, obviously, to x minus 3. So if you're noticing a pattern with these, basically, you know, you start out with nothing but negatives here, and then on the other side, you end up with nothing but positives. It all works out for quadratic inequalities. So for -5, you know, it changes there, and then 3, positive, and then negatives. You get a positive, negative, and positive. Now, since this inequality, this version was negative, we want the negative part. So our answer as an interval will just go from -5 to 3. You know, you could do it that way very easily. Now, so here's an interesting thing. We could keep that -1. Now, that -1 itself will be an extra sign. Now, we know how this is going to factor. X plus 5 and then x minus 3. So basically, yeah, x plus 5 equal to 0, x will equal -5. X minus 3 is 0, x is going to equal 3. Nothing has changed here in determining the roots. However, here's the thing. So negative 5, which does correspond to x plus 5, oh, we have to make sure that negative or negative 1 will stay out there. So each of these intervals is actually going to have 3 things, 3 signs. So that negative that's on the outside, that's a continuous negative. Never goes away. So x plus 5, to the left and then to the right. And then x minus 3. Now, 3 negatives give you what? 2 negatives and a positive give you, and 2 positives and a negative. So, and since this inequality was greater than or equal, you want the positive. Now, am I going to require you to show me this 2 different ways? No. I'm just showing you another way to do it. That's all. As long as you're showing your work, do you think I care which way you do it? No. See? Isn't it great? See, this is what I love about teaching math. For a lot of these problems, there are multiple methods. That's what I love about teaching math. Process that you could do this next one. Now, there's a negative in front of the whole thing. So what I would do, and I'm going to show you how this works both ways. So let's take a negative 1 out of this. And that's going to give us 2x squared minus 5x minus 12 will be greater than or equal to 0. Now, what I'm going to do here is I'm actually going to rewrite this just over here. There's a reason I do everything the way I did. We're going to see this kind of 2 different ways. And this is going to be greater than or equal to 0. Now, the first thing I could do is I could just divide out by negative 1. Now, since I divided by a negative, what will happen to that inequality? We're going to end up flipping the inequality over. So ultimately, we get 2x squared minus 5x minus 12 becomes less than or equal to 0. So we can do this by factoring. And then after that, I'm going to show you the other way that it could have been done. So basically what we're doing is we're solving 2x squared minus 5x minus 12 equal to 0. So we're going to go ahead and factor this. We need 2 numbers that have a sum of negative 5 and a product of negative 24. And those numbers are negative 8 and positive 3. So basically, the negative 5x becomes negative 8x plus 3x minus 12. And then we factor by grouping. So I can take a 2x out of these, which will give me x minus 4 for that. And I can take a 3 out of this. And x minus 4, of course, that's all going to add equal to 0. We get x minus 4 times 2x plus 3 equaling 0. So, if x minus 4 is 0, x is going to equal 4. Now, if 2x plus 3 equals 0, x will equal negative 3 halves. Now, we have the root, or the critical value, and the corresponding factor. Now, keep in mind, we're looking for where it is less than or equal to. So we go ahead and draw our number line as usual. So negative 3 halves and that corresponds to a factor of 2x plus 3. And then you have your positive 4, which corresponds to x minus 4. Then you make your signs. Basically, remember, everything to the left is negative, everything to the right is positive. So 2x minus 3, negative here, but positive elsewhere. And then x minus 4, well, we got negatives here, and then a positive. So 2 negatives give you positive, we get a negative, and then a positive. And since the inequality effectively changed less than or equal to, we want the negative part. Now, we divided out by a negative. You could have also just done, the other thing that you could have done just as well with this is add 2x squared and subtract 5x and 12 from the other side. You could have worked that way. Ultimately, you would have been left with the same thing. Now, just for a lark, I want to just show you this. Now, keep in mind, we took out a negative 1. So, we already know how this is going to factor into 2x plus 3 and x minus 4. And keep in mind, this is greater than or equal to 0. Now, keep in mind, watch the negative 1 there. So what's going to happen, obviously we have negative 3 halves. That corresponded to 2x plus 3. We had the positive 4, which corresponded to x minus 4. But we also have this negative 1. So basically, there's going to be a negation or a negative the whole way down the line. So we do the sign diagram, obviously negative here and then positive for the 3 halves, and then negative and then positive here. Now, 3 negatives gives you a negative. Two negatives and a positive is positive, and this is negative. Now, what we wanted in this case was for it to be greater than or equal to. Now, you're probably thinking, why did I do this both ways? Well, because I can. But the fact is, you could do it either way. It makes no difference. Yeah, you could just do it either way. So if we get x squared minus 6x minus 11, that's going to be less than 0. Now, we want to kind of keep that in the back of our head because we're looking for the negative interval. But let's figure this out. X squared minus 6x minus 11 equaling 0. And we could use the quadratic formula or completing the square. Now, if you give me the roots as decimals, that's, you're going to lose points on that. I want them in simplest radical form. Let's complete the square. So, in all reality, we're going to move that 11 back. Now, what's going to complete the square? Well, half of negative 6 is negative 3. But negative 3 squared is 9. So that is what you're going to add to both sides. So this is going to factor in x minus 3 quantity squared, and then that's going to equal to 20. Now we're going to take the square root of each side. X minus 3 will equal plus or minus the square root of 20. Well, guess what? We've got to simplify the square root of 20. That's easy enough for you to do. Now you can do a factor tree, you can do whatever you need to do, but basically, simplest way, square root of 4 times square root of 5, that becomes 2 root 5. So x is going to equal 3 plus or minus 2 root 5. Now, so those are the roots here. Now, converting these to factors might seem kind of a pain in the butt to do. But rather than converting these into factors, I'm going to show you kind of a neat way to do this. Now, obviously, if we did these on a number line, what would the smaller of the two roots be? What would the smaller? 3 minus 2 root 5, yeah. And the larger of the two would be 3 plus 2 root 5. Now, you're probably thinking, I got to convert these to factors and all that. No. Watch this. So, let's call this root A. So basically, if A equals 3 minus 2 root 5, the factor is just x minus A. And let's assign B to 3 plus 2 root 5. So the factor is just going to be x minus B. Basically, to get from x to x minus A, if x equals A, then you just get x minus A. And then you can do your sign diagram ever so easily. Negative here, but positive here. And then For the second one, negatives to the left, positives to the right. We get positive, negative, and positive. Nothing's changing. Now, which of the ones do we want? We want the negative. So for that, the interval would go from parenthesis. Now, why is this a parenthesis? We're not included. 3 minus 2 root 5 to 3 plus 2 root 5. So basically for this one, it's a single interval. Or it's just between two values. If you actually go to the calculator real quick, x squared minus 6x minus 11, and we wanted it to be less than 0. Well, it's a little hard to see here. If we actually Wyman that, let's make that say negative 30, we definitely should see everything. Yep. It's below this axis in one single interval. That's it. Just a little icing on the cake for you. All right. I'm going to let you try the next one. All right, so we need to figure out what we're going to add to both sides. Well, half of 8 is what? And 4 squared is, so that is what you're going to add to both sides of this. Now, the purpose of completing the square, this will simply become x plus 4 quantity squared, and then that'll equal 28 over here. Now, we're going to end up taking the square root of both sides. So you get x plus 4 equal to plus or minus the square root of 28. Well, what we need to do is take a moment and break apart the square root of 28. So 28 would be 2 and 14. 14 would be 2 and 7. Oh, there it is. So since 28 is 2 times 2 times 7, it immediately follows that the square root of 28 is the square root of 2, square root of 2, square root of 7. And how many of the same square root do you need to get a whole number out of that? You need 2. So basically, this will just become a whole 2 times the square root of 7. So x plus 4 will equal plus or minus 2 root 7. Now, we can move this 4 over, subtract both sides, and we're going to get x equal to negative 4 plus or minus 2 root 7. Now, we're going to leave these in simplest radical form. Now, what needs to happen here is we're going to put this onto a number line. So we're going to put all this onto a number line. Now, the smaller of the two roots would be what? What's the smaller of the two? Yeah. you have negative 4 minus 2 root 7. Now, the circle is going to be left open. Why is that? Because it doesn't include it. Now, here's the thing. You could actually convert these to factors. Or I could just assign a random letter to this. I'll call this A. Now, for the other one, this will be negative 4 plus 2 root 7. Now, thing is, yeah, negative 4 minus 2 root 7 and negative 4 plus 2 root 7, you really don't need to use a calculator to see which one is smaller and larger. Now, what you do need to do, what will happen is when we get into polynomial inequalities, is, there will be a mix of radical ones and rational numbers. That's when you will have to just get them in place. So, now we're going to call this one B. Now, basically, if we had x equal to A, then basically the corresponding factor is simply x minus A. And then the other factor would be x minus B. Again, you could actually write the actual factors side by side, but this is just kind of a shorthand way of doing it. I mean, that's my opinion. I've seen this work very well. Hey, and guess what? The sign diagram, that is never going to change. So, negative times a negative is positive, then negative, then positive. Now, what we wanted, since it was less than, we want the negative in. So, ultimately, the final interval will go from parenthesis, negative 4 minus 2 root 7, to negative 4 plus 2 root 7. That's all.
So the sign diagram is always negative, negative, positive.
Pretty much. If it started off with, if the leading term was positive, yeah, it's always just going to alternate. So then you're wondering, what's the point? I mean, yeah, so basically, yeah, all right, so this bad boy, you get x squared plus 6x minus 39 less than or equal to 0. So we're going to be looking for the negative sides of this. So x squared plus 6x minus 39, that's going to equal 0. So that we can find, we'll be finding the roots of this. Let's use the old-fashioned quadratic formula, because it's so much more fun. Oh, it's fun for me. All right, so when we want to use the quadratic formula, we're going to figure out the discriminant, which is b squared minus 4ac. That's 6 squared minus 4 times 1 times negative 39. Now, if you complete the square, don't freak out. we get 192. So we got to figure out the square root of 192 in simplest radical form. Well, that's going to take us a minute. So I can just keep getting some 2's out of there. Oh, 2 and 96. Or I like to do 96 and 2. Yeah. 48 and 2. 24 and 2. 12 and 2. 6 and 2. And 3 and 2. Dang. So we have 1, 2, 3, 4, 5, 6 2's. And a 3. Now, of course, I could have just used my computer algebra system and gotten the simplest radical form right there, but I figured let's have a little fun, just do it the way I had to do it back in my day. Now remember, pair them off. These two got a date to the dance, so do those two, and so do those two, but that square root of 3 is going stacked, but the thing is, that's okay. I went to my homecoming dance stack senior year, and I'll tell you, I had a good time. Yeah, well, within the boundaries of our law, anyway.
The best way to go is by yourself.
Yeah, now prom I had dates. I mean, that went to show that, yeah, I could get, if I could get dates to the prom. All right, let's figure out the rest of this quadratic formula. So that's going to be -6 plus or minus 8 root 3 over 2a, which is 2. So basically, in doing this, don't die on me here. No, you're -3 plus or minus 4 root 3. So those are the solutions to this. So now we can put them on a number line. So if we do, let's see, -3 minus 4 root 3, let's call that A. Now, by the way, will the circles be filled in or will they be left open? We fill them in. And of course, this is x minus a. I mean, yeah, you could write it out lengthy, but what's the point? You're going to get the same thing. And the other root, which that one's going to be -3 plus 4 root 3. Let's call that b. I mean, you don't have to use a and b. I could use L and Q. So for A, left of that is negative, but right of that, it's positive. For B, left is negative and right is positive. Nothing's ever changing, is it? Nope. Positive, negative, positive. Which one do I want? Since it's less than, I want negative. And so the final interval is going to go from, this time we're back to brackets, -3 minus 4 root 3 to -3 plus 4 root 3. Bracket. All right, not bad, is it? All right. I want you to start on the next one. How can you use the quadratic formula? So A is going to be 1, B is going to be -4, and C is going to be -146. So we always want to find out the discriminant first. Here, is 4 times 1 and -146. We get 600. Now, the fact that, yeah, square root of 600 seems like a pretty imposing number, but the fact is, it's actually not so bad because I know that 600 is just equal to 106. So basically, we get 10 root 6. So we would have 4 plus or minus 10 root 6 over 2. Ultimately becoming 4 over 2 plus or minus 10 root 6 over 2. Well, 4 over 2 is 2. 10 over 2 is 5, so plus or minus 5 root 6. There's our roots. 2 plus or minus 5 root 6. So basically, the smaller one is 2 minus 5 root 6. Let's call that, well, let's call that T. I like T better. You can call it A, B, or whatever you want. And keep in mind, since it is included, we fill in the circles. And then 2 plus 5 root 6, let's call that Y. I don't know. I feel like doing it that way. But basically, you know, X minus T, X minus Y. I mean, the fact is, you'll know, you probably will, yeah, as Isaac had pointed out, it goes positive, negative, positive. It's always the case for quadratics. But why am I bothering with this? Well, I want to be thorough. Positive, negative, positive. Now, before okay, so I needed it to be greater than or equal to. So it's going to have 2 separate intervals. So basically, we go from -infinity to 2 minus 5 root 6, bracket, union with 2 plus 5 root 6 to infinity. All right, so let's factor this, or we could do basically any other method to solving this. I'm going to go ahead and factor. So our required sum is 11, and our required product is -210. Because remember, 6 times -35, oh, that's easy, 21 and -10. So we're going to do the wonderful factor by grouping method. So we get 6x squared plus 21x minus 10x minus 35 equaling 0, of course. So let's see, 6x squared and 21x. Now, you could have done this completing the square or using the quadratic formula. It makes, excuse me, no real difference. So I'm going to take a 3x out of this. So I will get 2x plus 7 I'm going to take a 5, negative 5 out of this, so I'll get 2x plus 7 yet again. So we get 2x plus 7 times 3x minus 5 equaling 0. Well, we just have to figure out these two factors. So 2x plus 7 equals 0. 2x will equal negative 7. X will equal negative 7 over 2. That's one of them. And the other is 3x minus 5 equals 0. 3x will equal 5. X will equal 5 over 3. So let's do this thing. Let's do our sign diagram. So the smaller of the two is negative 7 over 2. And since it is less than or equal to, we will include fill the dot in. Now that corresponding factor is 2x plus 7. Now the other one, 5/3, and that is 3x minus 5. So we do our sign diagram as usual. See, it's almost like systematic after so long. So we get positive, negative, positive, and since our inequality was less than, we want the negative part. Negative 7/2 to 5/3. All right. So just like before, we have to solve the related equation, 5x squared 32x minus 21 equaling 0. And we could factor, or we could complete the square or use the quadratic formula. I'm going to go ahead and factor. So we need a sum of 32 and a product of negative 105. So let's see here. Let's see if we can come up with some numbers that make that work. Let's see, 35, positive 35 and negative 3. So I could take out a 5x here, getting us x plus 7. I could take out a negative 3, and that'll give us x plus 7 equal to 0. So we get x plus 7 times 5x minus 3 equaling 0. All right, not bad. So with that, x plus 7 equaling 0, obviously x is going to equal negative 7. And 5x minus 3 equal to 0, well, that means 5x is 3, x is 3/5. So what I'll do is I'll put them on the number line, and if you don't show your, thing is, if you realize it's positive, negative, positive, like here's negative 7, and then here's 3/5. Double negative, and then double positive. So basically, we would be going from negative 7 to 3/5. All right, so let's move everything over to one side. So 6x squared minus 5x minus 25 is greater than 0. So ultimately, you know that 6x squared minus 5x minus 25 equal to 0. Let's do the quadratic formula, because I feel like it. You could have factored. Yeah, so if it's a leading term that's something other than 1, it will be factorable. That, like, if you had that on a test. So minus 4 times 6 times negative 25. And we get 625. And the square root of 625 is simply 25. So basically, the quadratic formula is 5 plus or minus 25 over 12. So 5 plus 25, that's 30 over 12. Let's see, I can divide them both by 6, so that's going to give me 5 over 2. And then for this one, we'll get negative 20 over 12. If I divide by 4, I get negative 5 over 3. Now, what could be, you know, what might fluster you here is the fact that, yeah, these are, what's it called, you know, rational solutions. And, you know, when you do the sign diagram, you know, typically one lists the factors that are next to it. Obviously, the smaller of the two is negative 5/3. Now, you could just do, you know, x plus 5/3 doesn't make a difference. Or 3x plus 5. Again, makes no difference. Now, why did I leave that open? It's not included. And then 5/2, well, that's the same as, you know, x minus 5/2, or simply 2x minus 5. So let's see, for negative 5/3, that one, then we get two positives. Yeah, see, none of this is changing at all. It's all the same thing. Positive, negative, positive. And do I want the negative or the positive? Greater than. Positive, that's okay. So negative infinity to negative 5/3 bracket 5/2 to infinity. Is that the correct interval notation representation? No. You're meaning to tell me I did something wrong? Yeah, you're fine. Yeah. Don't. I'm just totally messing with you. I did that on purpose. You're supposed to have parentheses. Yeah. Don't ever be offended to tell me, hey, I don't know if you did that right. How to do the quadratic formula. Now, if you factored, that's fine. So let's see, negative 5 squared minus 4 times 12 times negative 2. Of course, that's your discriminant. minus 4 times 12 and negative 2. Let's see, we get 121. And the square root of 121 is simply 11. So, doing the quadratic formula, we get 5, positive 5, because remember that's negative b, plus or minus 11 over 2 times 12. You have 5 plus or minus 11 over 24. So we get two solutions, which are 16 over 24, which is 2/3, and negative 6 over 24, which is negative 1/4. Now, you're probably thinking, oh man, I still got to make my sign diagram, but I didn't factor this. Well, guess what? You have another option here. So for this, all you got to do, let's put those here. Here's negative 1/4, and this will be x plus 1/4. Or you could do, 4x plus 1. It makes no difference. And the other one, 2/3. X minus 2/3 or 3x minus 2. Basically, same rules apply. So we want the positive versions, which are here and here. So we get negative infinity to negative 1/4, parenthesing that union with 2/3 infinity. Equation. So if we go ahead and do that, you can't factor this, and c will equal 10. So basically, if I do the quadratic formula, that's going to be negative 4. So the square root of negative 4 is going to be 2i. So basically, we get 6 plus or minus 2i over 2. Ultimately, that becomes 3 plus or minus I. Now, here's the thing. You can't do an interval with this. This one is a special case one. So if you have, x squared minus 6x plus 10 greater than 0, x squared minus 6x plus 10 less than 0, if you let x equal to 0 in each of these, basically you get 10 is greater than 0. This is true. And 10 less than 0, this would be false. Now, since it had imaginary solutions, this inequality is basically true for all reals. And this version would be no real solution. Would I ask you something like that on a test or a problem set? No, not anymore. So basically, x squared minus 6x plus 37 equaling 0. If I want to complete the square, and what will happen is to complete the square here, I'm going to add 9 to both sides. And I get x minus 3 quantity squared equal to negative 28. Now, when I take the square root, oh, look at this. I've got imaginaries. X minus 3 will equal plus or minus 2I root 7. X will basically be equal to 3 plus or minus 2I root 7. And what will happen is, basically, there's no real solutions to this. Well, basically, it's either going to be, so basically, all you have to do is pick a value for x, particularly 0. If you have x squared minus 6x plus 37 greater than 0, or you have x squared minus 6x plus 37 less than 0. Now, if you let x equal to 0 for either of these, here's what will happen. You'd have 37 greater than 0, which is true. For this one, you'd have 37 less than 0, which is false. Now, here's the thing. These are true and false for all real numbers. Now, the thing is, I'm not going to give this to you on a test, but I just wanted to make you aware of it. That's all. So what happens here, so what we get here, a polynomial is an expression that's going to have positive integer exponents and real coefficients. So this is the general form of a polynomial. This scares you probably, but don't let it. Basically, n is the highest power, so that's what the degree of the polynomial would be. Now this is the leading term. And this here is your constant term. Now, of course, there isn't a power of 1 for x shown there, but that's what the power would be for x. Now, theoretically, we could do polynomials of massive degrees. The most you would see here would be fifth degree polynomial. And that's really pushing. You could do, like I've dealt with 12th degree polynomials. But it's just more work. So, we need to determine whether each of these expressions is a polynomial. So for this first one, you have negative 7x to the third minus square root of 3, x squared minus 5. This is a polynomial because all the exponents are positive. Now, even though we have a coefficient of the square root of 3, that is still a real coefficient. So what would the degree of this be? It would be a third degree. Now, how about for b? Is that a polynomial? No. Because basically what happens if we have that x to the third in the bottom, basically that is the same thing as saying negative 5x to the negative 3. That's not positive, so basically that's just a big no. Now, how about for option C? You think that's going to be a polynomial? Well, square root of x is x to the 1/2. And it has to be an integer, so that's a no. Now, we're only going to be dealing with polynomials here, nothing like B or C. So that's what you're going to get. Now, graphing functions and turning points. Basically, a turning point is where a function changes direction, and a polynomial of degree n will have at most n minus 1 turning points. So, for instance, if the degree was 2, now a second degree polynomial, now think about that. That's what we've been working with this entire unit. How many turning points would that have? No, 1 turning point. Now remember, yeah, second degree polynomial basically just has a min or a max, 1 turning point. A linear equation would be a degree of 1. Linear means it's a line. It doesn't turn. Here's something a little extra. I mean, basically, in a class I took as an undergraduate called abstract algebra, I actually had to prove this, that a polynomial of function degree n would have at most n minus 1 turning points. I actually had to prove that for generality, and the proof is ugly, but I'll admit, when I was an undergraduate, I basically memorized the proof. But now I look at it today and I'm like, oh, that's what it is. Wow, makes sense. Now, smooth, continuous graphs have rounded curves and no sharp points with no breaks or graphs. Those are perfect examples of polynomials. A graph that has kinks and breaks or gaps, that's not a polynomial. Now, end behavior of polynomial functions. We talked about end behavior of functions. Basically, so far we've only done this with quadratic. What degree for quadratics? Second degree. So basically, if you just choose a random, make a random even degree function with positive and negative leading terms, so like I'm going to do something like this, x squared minus 6x minus 11. So basically, if f of x is positive 1x squared minus 6x minus 11, this is a positive leading term. And basically for this, as x goes off y, which way does y go? It'll go to positive infinity. Now, I want you to graph this function, just preferably in your calculator. Negative 1/2 x to the fourth plus 2x to the third. That's even degree because the highest degree you see is a 4, which is an even number. So if we punch that up in our calculator, negative 1/2 x to the fourth plus 2x to the third and if I zoom 6 it, and I'll change that y-max to something a little bit bigger so you can see it, but here's the thing. It had a negative leading term. And since it had a negative leading term, that basically is just going to change it. So the ends, so as far as end behavior goes, that's a negative leading term. So as x goes off in both directions, where's y going this time? We're going down. So really, what I really want you to notice is that the end behaviors are going in opposite directions. So as x goes to negative infinity, where's y going? Positive infinity. And as x goes to positive infinity, where is y going? Negative infinity. So this is a negative leading term. Now, for positive leading term, as x goes to negative infinity, y goes in the same direction. And as x goes to positive infinity, y will go to positive infinity. Now, so basically, odd degrees have end behaviors that are going off in opposite directions. Even degree, they're in the same direction. So basically, what you would see on a test is 2 end behavior questions. You have to circle 2 parts. All right, so basically, we can combine this with finding zeros using the graphing calculator. So we're going to kill 2 birds with 1 stone here. Now, zeros of polynomial functions. Now, if you remember, zeros, roots, solutions, and x-intercepts, that's where the other side is equal to 0. Now, basically, a fundamental theorem of algebra, the degree is the total number of solutions. And multiplicity is number of times a factor or a 0 occurs. And multiplicity of 0 will also determine the behavior as to how it would cross the x-axis. Now, we can use the graph or polynomial root finder to find any zeros. So what we're going to do here is we're going to find zeros of this. Now, we're going to see them both using the root finder and the graph. Now, out of curiosity, what is the degree of this? So how many zeros should there be? There will be 3 zeros. So let's do this. X to the third, and that's minus 6x squared plus 3x plus 10. And I'm going to zoom 6 this to get our standard viewing window. Now, the thing is, we may need to, don't ever zoom out. We're only going to change the Ymin and Ymax values. Now, the x-intercepts will always be between -10 and +10. Whether they are rational or irrational, it doesn't matter. So we're going to basically kind of see everything with the calculator first before we actually get into the real algebra. So let's make this Ymin -15 and Ymax 15. And what you see here is you see a nice function here that does in fact have, I mean, how many times does it cross the x-axis? 3 times. And you can very easily see where that happens. This first one is at equal to -1. This one is where x is 2, and then here is where x is going to be 5. Now, if you did this, -1, 2, and 5, you can see it just like that. Plain and simple. Now, let's say we go to apps now. And you should have the polynomial simul 2, so polynomial root finder. Now, the order, which is the same thing as degree, this is a 3rd degree. And let's just keep it real for now. And here you'll enter the coefficients. You can also change the sign between those. I don't do that. I actually would put, obviously 1x to the 3rd, and then minus 6x squared, -6, and then 3x, and then 10. You're going to solve this, and we see the roots exactly what we calculated. So there's nothing new about this. You know, 5, 2, and -1. Now, when we do some more algebra, particularly in the next class, that's going to come, that's going to make this come into play a little more. So, you guys, we still got a couple minutes here. Come on. So, what happens as x goes to -infinity? Where's y going? Y is going to go to -infinity. What happens as x goes to +infinity? We're going to +infinity. Now, because these three roots are very basic, if you actually converted each of these to factors, x equals -1, x equals 2, and x equals 5, if we converted all of these to factors, what would happen, this would be x plus 1, x minus 2, and x minus 5. If you actually multiplied all three of these, now you can't multiply three of them together, you would have to do them two at a time. But what happens is, ultimately, you get x to the third minus 6x squared plus 3x minus 10. No, plus 10. Plus 10. So pretty cool how it all works. All right, any questions on this? All right, so I will not see you on. So my question is, how many times does this cross the x-axis? Crosses 3 times. Now, obviously, it's a third degree. That's how many times it should cross. Now, imaginary roots won't cross. But there's I'm getting way ahead of ourselves here. But how many turning points does this have? It has 2 turning points. Now, this would be a maximum, and this would be a minimum. Now, we would use the calculator to figure this out, but all I really care about is finding out what the zeros are for this moment and the end behavior. So I think this is a 0 of -3. So if I go here and I type in -3, I do get a 0 there. And give it to me as ordered pair or x equal to -3. Now, how about this one? This is at 1, 0. So looking at this graph, 2, 3, 4, 5, 6, 7. Yep, 7. Yep. So here's the thing. We do have 3 roots. And we've verified that with the graphing calculator. Now, the really fun thing, really kind of nifty thing, we're going to use the polynomial root finder. So to access that, we go to apps and polysimul 2. And polynomial root finder is where you will go. And we want a third degree. Now, we're only going to stay with real for the time being. So with this version, you can change the signs. I don't like doing that. Instead, obviously we have a leading term of 1. Then we'll have -5. And then we'll have -17. And then +21. Now we go to solve it. Here are the roots. 7, -3, and 1. So this can be used as a supplement. So I think this is actually really cool how this works. Now, let's knock out the end behavior. So basically, as x goes to negative infinity, where's y going? It's going to negative infinity. That's right. Now, as x goes to positive infinity, where's y going? Positive infinity. Yep. Same exact idea here. Now, I'm going to get a little bit ahead of ourselves here, but this is a maximum point, and this is a minimum point. Now, because this is a third degree, you would actually have to use the calculator to figure this out. Otherwise, you'd have to use calculus. And why would you use calculus if this were, what's the title of this course? Pre-calculus. But, when you go on to take calculus, basically you would find the derivative of this, which would be a second degree. And set that derivative equal to 0. Basically, you lose a degree when you find the derivative. And what happens is, that's one of the reasons why a third degree could have two turning points, because its derivative would be a second degree. But that's a little bit ahead of ourselves here. Now, before we end this, so I'm actually we'll take this a little bit further here. So we already know our roots, which were x equal to -3, x equal to 1, and x equal to 7. Let's convert these to factors. Well, that's easy. Basically, this becomes x plus 3. What would the factor resulting from this be? And the factor resulting from this. Now, when you multiply, you can only multiply two of these at a time. So you have to multiply these two together, and whatever the product may be, which will be a quadratic, you multiply it by this. However, I'm going to cut to the chase. And we're going to use this to show you. And basically, this is going to kind of prove to you how I come up with everything. Come on. So, add calculator. So, what happens here, the technical term is to expand, and I do the three factors, x plus 3, x minus 1, let's make that big. Then x minus 7. We get x to the third minus 5x squared minus 17x plus 21. Hey, doesn't that sound familiar? Plus 21. So yeah, basically, whenever I come up with these polynomials, you will, I basically use my TI Inspire or any other computer algebra system calculator I have in front of me to do that. So, and real quick, I'm not going to start on the next one here, but I'm actually going to bail out of this. Now, if I go to the graph, I hit second in calc, the minimum, I could take this spider to the left, and then take it to the right, bypass that guess thing, and that's what we get. So that's what you would be using to find the minimum and maximum points. Yeah. And yeah, the student will ask me, hey, can we do that without the calculator? Yeah, you can in calculus. All right, so that's